Oh no. Welcome
What? Oh,
YouTube.
no.
We missed the first half an hour.
Woohoo!
I turned on my recorder. I know for a fact that I turned it on.
Oh no, they
But
missed all my great quotes.
But apparently it's turned off now. If you're watching this, I very highly recommend you to read through lecture 1, like the slide deck yourself. Yeah, I don't know what else to tell you. We missed the first part. My recorder turned off on itself. We're gonna continue because we've been doing this for an hour already. Good luck.
They
Might
must
be a good
really-
idea to show what part of Grasp we're on right now.
Yeah, we are currently doing. Wait, can I do this? Yeah, I can. So we have done all these, and we're currently done basically with the last part of 1. We have just drawn a lot of these things. Honestly, that's all it really comes down to. So pause the video,
Get ready
watch
for
that first. Like
probability
watch that slide deck first. Try to really intuitively grasp it, and then come back here. So we know A and B are events. We know the P of A complement given B complement is equal to 0.16, and we know PA cup B is equal to 0.92. We want to know P of B.
But when's lunch break?
Lunch break is gonna be I think when we're done with lecture 2, I guess. We can also do it once we're done with lecture 1. I'd be down for that. I don't really mind too much. But yeah, we want to know this. Well, this is gonna be easy, right? Because I'm gonna say we want to know this. I can say P of B complement is equal to 1 minus P of B. Alright. So now we have P of B complement. We can multiply this thing by this thing to get, let's see. If I multiply this thing by P of B complement is equal to P of A cap. Is that cap? Yeah, cap B. So A and B in this case is equal to 0.16 times 1 minus P of B. Oh, and I need to put a new line here.
Also, don't forget that that basically
Yeah, this is not correct because this is actually probability of A cap or A complement and B complement.
Yeah.
So
which is the same as 1 minus AUB, basically.
Exactly. So
So
that is a good one because that is like indeed the complement of P A cup B. Because again, 1 minus chance of something is equal to the chance of that complement is equal to yeah. So if we take this complement, we get A cup B complement is equal to A complement cap B complement, which is what we have here. And we know this. So we know this is equal to 1 minus 0.92 is equal to 0.08. However, we don't want to know this thing. We want to know this thing. So we now know that this thing, oh, I forgot my P, is equal to 0.08. However, that's not, we don't really care too much about that. We care about only this thing. However, we know the chance of this thing. This is 0.16. So we can say P of B is equal to, or let's start with P of B complement is equal to this thing divided by this thing, because again we can divide both sides by that. That's no problem. Recompile. Oh, I fucked up
But
somewhere.
wouldn't the splits thing be a bit better in the bottom right corner?
Hmm?
Where it wouldn't take up any space over the progress bar.
Bottom left corner, maybe.
Yeah, sure. Good one.
Or bottom, I'd say bottom right.
Yeah, it doesn't really matter too much. Either way, so we know this thing. And we also know that this probability is equal to 0.16. And there we have it. So this is actually equal to like 1/2. Ooh, actually, I was about to say that is not all. Because this is P of B complement. We need to do 1 minus this, but 1 minus half is half.
Damn.
Damn! I love how you can do the wrong thing and you still get the correct answer. Damn, boy. That was probably
Yes,
really
those
rare to get
five
like.
those 5 decimal points were definitely needed.
Hmm?
It gave the results like 0.50000000. In the last one, like instead of 0.50 or something, it had like 5 zeros after the 5.
Yeah.
Yeah.
Let's
mean-
play cards. Oh boy. We have a special deck of cards, 15 clubs, 10 die. What? We draw two cards without replacement. Draw a probability that the second card we draw is a club, given that the first card is also a club. Okay. So I'll say A is first card is club, B is second card is club. So we know the P of A is equal to 1 in, or actually not 1, sorry. We have 15 clubs out of 58. It does not like it when I put this stuff inside of my latex like work. So give me a sec. There we go. So A is first card of the club, B is second card of the club. So A, the chance of A happening is this. Now we have to figure out some formula. We know that the P of, let's see, B given A is equal to the chance of P and A, or sorry, P of B and A over P of A. So we have P over A already, which is good. And we can also manually calculate the chance of P of A and B, or in this case B and A. Because then what we should do is we have P of A and B. So first we draw card A, which is this one. And then we draw card B out of a deck that is yeah, that has already gotten card B drawn out of it. I am thinking way too complicated for this. We have a deck like this. We know that the first one is drawn is already a club, so we can actually say that the chance of this is equal to 14 out of 57. Because the first card drawn was a club, so there's only 14 clubs left out of 57 cards left. I shouldn't have done any of those maths. This should be correct.
Yes, that should be.
Do you guys understand that like thought step that I did just now? Because that probably went really quickly. I'm not hearing yes, so I assume that's a no.
That was
Mm,
pretty.
I understand.
Pretty obvious.
Okay, cool. Then I assume it's yes. Cool. Okay, back to actual calculation shit again. Sad. So we have A and B, and we have B given A. Wow, this is like really easy. So we have P of A equals 0.88. We have P of B mid A complement is equal to 0.62. We can get P of A complement is equal to 0.12 by 1 minus P of A. We can get P of B cap A is equal to P of B mid A this is incorrect. This is P cap A complement. Is P of B given a complement times P of A complement. Every time I'm talking about A complement, I think of just any. Pick a complement. So this is equal to
You have really nice eyes.
pick a compliment. Damn it, man, really got me there. C dot, and then a complement of 0.12 is equal to
I like your programmer socks.
ooh, this is a real college moment. 62 times 0.12. So this is the chance.
Those socks make those thigh makes me want to say hi to those thighs.
Hi thigh, hi thigh.
Program
Um,
Okay, okay, but is there anything better than thigh highs?
I'm willing to debate you on this, but not now.
Not on video.
Not on video.
Follow
Okay.
my
I'm
OnlyFans for more.
Before I'm gonna say something really dumb.
Yeah.
The course lecturers are watching this back like, this
Yeah.
guy is putting our material online. This is the is he talking about thigh highs?
Yeah. Follow my OnlyFans for more.
Matteo. Okay,
Wink, wink.
FBI, open up. So what we want to know, what we want to know, if we want to know the P of A and B, so we care about this thing. We know right now what the chances of B happening and not A happening. So we know this thing. To calculate this, the easiest part would be having access to B, because the entirety of B minus this part, so B given not A, or B and not A, would be equal to this. Do we have any way to get the probability of B itself? Not quite. Do we have any ways of getting? So we know B and not A. We can get the chance of A and not B by doing 1 minus that. Let's see if that gets us any further. Because at this point, this is interesting. Because right now I have no idea. Let's see. So P of A cap B complement is equal to 1 minus P of B cap A complement. And again, we have done this before, but if you do 1 minus this is equal to the thing inside of here, this is wrong. This should be a cup.
The union.
So again, we're going to do the Morgans here once it recompiles. So yeah, when we apply the Morgans here, we will get B and A complement. So that will become B complement or A, and that's what we have here. So this is equal to 1 minus this thing, which is 1 minus 0.0744, is equal to 0.9256. What does that give us visually? So this is the chance of A happening or not B happening. So that is everything except for this part, which is pretty logical because we took complement. That doesn't help us whatsoever.
Fuck.
And we care about the middle part, right? We want to know chance of A and B happening. Is there a way to turn this from...
You can just do the fourth line plus P of A, right?
Wait, what do you say?
The fourth line,
This one?
yeah, plus
Yep.
P of A.
That's P of A?
Yeah. Like if you look at it at the picture, it should make sense.
So we have P of B and not A. That's this part.
Mm-hmm.
But how does this help us achieve A?
No, plus P of A. You
Oh,
already
wait,
have P of A.
wait, wait.
Can I see the question text?
It's A or B.
Yeah, A or B. Okay.
Yeah, okay, then you're right. Then it's just this plus A. Yeah, okay. Okay, yeah. That's on me, that's on me. I'll take the L. So that is P of A, that's 0.88 plus this thing. Is that correct? No, plus this thing. I was about to say, then we would have like 1 point something. That's not gonna happen. plus this thing. And if we
So 0.95.
there we go. Damn, that's yeah, okay. That was just my bad for misreading it. I was like, oh, we're gonna use some kind of new fancy trick, but that's just my bad. So far, to be honest, we are on pace for green percent.
Yeah, this is going fine.
Okay, lecture 2. Law of total probability, base independence, bunch of other stuff. Let's see. Am I still recording? Yes, good.
I think
We
I'm
have a choice. We can either do a lunch break now or in an hour.
Are you hungry?
I think now I'm hungry. If that's fine
I
with
think
everyone.
now it's lunchtime.
Okay, everyone is
So-
doing lunchtime.
In
Uh,
that case, does
Speedrun
anybody
lunch
want to see a,
percent.
would anybody like to see a cursed plane in KSP?
Kurt, what?
A cursed airplane?
Sure, you did NVC channel.
Yeah, sure.
Oh, or shooting share, I guess. Oh, Kerbal Space Program.
Yeah.
Why? I'm not a cat.
I will show you why it's cursed, and that is because the takeoff half the time I will get rid of this these rear fins, but it still it flies pretty stable, and it does not look like this should fly stable.
It looked like a cat.
Yep. Anyway, guys, we have dinner
How
until
does this look
12:45. I think that's like 13 minutes. I'm not sure if that's enough, but you know, just
Dinner
stuff bread in your face. It'll be fine.
But how is this stable?
I don't know. I mean, it's symmetrical. That's important.
Yeah,
Uh,
there we go.
it's stable, but you're not a stable
Ah.
flight.
Okay. Now what shall
Want
we
to
build?
do that?
Okay, this will be the computer science aircraft. What are we making?
Make it a large dick. Haha, funny penis
Haha,
moment.
funny. Okay, I'm having lunch. See you guys in
I
30
did.
minutes.
Yeah,
Bye bye.
okay, good luck, guys.
Already did that last time. The new idea I need.
Wait, no, it fucking clicked the fucking.
I don't care, at least give it a rudder this time.
No, I.
Repeat.
At least give it a rudder this time.
Okay, just decide which cockpit I'll go for. Options include this one, that one, that one, that one, and that one. That'll be the one.
Someone clip this and edit this to be like, help me decide which cock I'm looking for.
Help me decide my future cock.
Trans people be like.
Damn, I think we're gonna have to go into my cock safe then.
Something, I'm gonna get lunch.
You know, this is a nice head. That's a nice tip. Don't you agree? Conrad, do you like that tip?
I'm not watching.
Bruh. Actually, wait a minute. Well, Well, if anyone happens to be here, enjoy. I like how I'm literally the only one here when the time has already arrived. Anyone here?
Hello,
Hello.
I am back. I lied about the
Hello.
45. My parents made soup and it was fucking hot.
Is he making a cock rocket? He's making a cock rocket.
No, it's a cock plane.
Oh, then it's okay.
Oh. Okay. Yeah. No.
I'm
fine.
so
Yeah.
mad you missed the choice for a cocket.
Anyway, let's continue, guys.
Just enjoy how beautifully it flies for 1 minute first.
Hope that isn't too bad of a sound for you guys.
Huh?
I'm opening a package. I said I hope it's.
We're not hearing jack shit.
Ah, boogers. This mic is good.
Imagine not having a Cloud Hyper X2 something.
Imagine not having some, I think, Steel Series Arctic 7 or something. Fuck. Ah, whatever.
And lost this. No, he lost half of his testicle.
Oh no.
It's fine.
Imagine not knowing what's going on.
Didn't need it anyways.
Yeah.
He had cancer.
Imagine watching this on YouTube and not seeing the screen share.
Boo.
HSS Cockets now with half less testicle. This is just me making sure you're against demonetized, by the way.
The best part is that it flies pretty well. Like we're having all the wings at the back there and flying subsonic, it flies exceptionally well.
Nice.
It's even got little hairs.
Alright. Let's continue with lecture 2. Oh yeah, I can't do it like that. Damn it. So you guys can see my screen, right? We are going to talk about independence and... This should be better. We're going to talk about independent and discrete random variables.
One thing's for sure is that I'm not a very discreet.
Uh,
I'm also not very independent. I still live with my parents.
me too. That's boggers, don't worry.
True. You're your timer.
Thank you! Okay. Independent. Two events are called independent if for each collection it holds that the union of those events is equal to the product of the probabilities. Or I should say the probability of the union of those events is equal to the product of the probabilities. Yeah, that makes sense. You have a system consisting of n components. If all the components function, is a chance of all the components functioning independently. Yeah, that makes sense. The problem that this thing functions is 1 minus all components fail. Yeah. And again, because they're independent, you can just pull this outside. Let's see, does that make sense for me? Yep, cool. Discrete random variables. Let's see, if we throw 2 dice and let m be the maximum. Okay, I have no clue what this thing is, so I'm just gonna continue.
What thing is?
Like the...
M is a random variable which gives you the maximum of 2 dice, which converts from the output space to the real numbers. M is a random variable, like X or Y.
Oh yeah, okay, I see.
So yeah, you get that shit where like the P of M equals 2 is the thing that the highest of the dice of the 2 dice is 2, etc. You know, X or M or a random variable is just a function which goes from the output space to the real numbers.
Yeah. and because it's a discrete random variable, it's from the output space to the integers, right?
The fact that it's discrete means that there are that there's actual tangible. No, I'm not too sure on that. Someone
Okay,
else.
so I know like the difference between
discrete-
discrete and uniform is that when you have a uniform number, the chance of something being exactly like 4 is 0 because, well, it's
Mm,
Discrete literally just
discrete
and
means that
discrete literally just means 1, 2, 3, 4, 5, and so on. That there's no like that is
yeah,
not
everything has the
continuous.
same chance.
everything is defined.
not
Yeah,
everything having the same
discrete-
chance.
Oh,
No, discrete just means that there's like
Discrete values which have a probability. So the difference is between discrete and continuous. Continuous means that there is like that the chance that a single
There's
a
an
single
area.
value, thinking of a single value doesn't make sense. In cases with, for example, dice, you can think of a single value and it makes sense.
Yeah, like if you're thinking about like for example, say a uniformly distributed, or not a uniformly distributed, but like a normal distributed height, right? There is
Yeah.
a chance of 0 that when you pick one, it will be exactly 1.8. There will
Yeah.
always be at least some bit off.
Yeah,
And that's
but
why
if-
you
if
usually
you-
take
if
the
you-
area under, right?
Yeah, but if you take if you group them into buckets of like from 1.8 to 1.9, from 1.9 to 1. From 2 to 2.0, that's discrete again, because then it makes sense to talk about one value.
Okay.
So that's the difference between discrete and continuous.
A discrete random variable is a function x that goes from the sample space to a real number. So it doesn't have to be like 1, 2, 3. It can also be like 1.5, which makes sense because you can say like, I have a discrete
Yeah,
random
just dice.
variable. I throw a dice. What is the number divided by 2? Or an infinite number of values. Okay, that makes sense. Yeah. Okay, so this makes sense. This is just it takes on values. Probability mass function. That is only for discrete random variables, right? So a probability mass function is not does not exist for a continuous random variable. But we have a discrete random variable, and yes, then it will give you the chance that that variable is equal to that thing. So here we have like this one here is a good example. The maximum of 2 dice. So the maximum of 2 dice being 1 is only 1 out of 36, namely 1 and 1. The maximum of it being 2 is 3 out of 36, namely 1 and 2, 2 and 1, and 2 and 2. So here at these points, this function exists, and it means
Well, it exists everywhere else, but it's a 0.
yeah, okay, yeah, it exists everywhere else. It's just 0, but like at these points, it's not 0. Namely, it is these things, and this makes sense because we can ask what what is the chance that the maximum of 2 dice I've thrown is 4 is equal to what's the chance of x being equal to 4 or p of 4 in this case, and that would be 7 out of 36. Yeah, and here on the left you can also see like the table for the probabilities of 2 dice, whatever. Then we have the distribution function. Again, this was the mass function. The distribution function is the total amount to that point, which basically means it's the sum so far. So the f of, for example, 4 is the chance of 1 plus the chance of 2 plus the chance of 3 plus the chance of 4. And again, this makes sense here because the probability of x smaller than or equal to a is equal to the probability of x being 1, probability of x being 2, 3, and 4, because it's discrete. So at the rest of the things, the probability is just 0. Make sense so far?
Mhm.
And again, I am going to rewind myself 20 times. Distribution is the sum. Mass is the
number.
the number itself for discrete, because that's gonna fuck me over.
I mean, I don't think mass or distribution exist for the other one. I think it's density and just density, because mass doesn't make sense for multiple.
Yeah, like
That-
when
Yeah.
you
If I recall correctly, that is.
Density and cumulative, or well,
Yeah. Yeah, that's basically the analogies in continuous, because cumulative also has the maximum value of 1 and then just keeps steady.
Mm-hmm. Okay.
Wait, give me a sec. Okay. Discrete distributions. Okay, yeah. So this can never be a distribution function, because a distribution function only goes up. Again, it's the sum, and you cannot have a negative probability. And this one, well, this one is exactly 1, so there is, like, everything else would have to be 0. Okay.
Yeah.
Oh, and then we have this thing. Do we have to know the formula by heart, or is it on the formula sheet? Like from the binomial coefficient. Ah,
I think we
hey,
have.
let's go, let's
Yeah.
go.
Woo!
Let's go.
Uh, okay, let's see. Oh yeah, and here we have like pick 1 from everything, times pick 1 from everything but that one, times pick 1 from everything but those two. So again, this is just factorial. Or not factorial, sorry. It's like factorial with a limit, if you get what I mean. Let's see, transmitting a message with errors.
I don't, but it's on the paper, so.
Fair. Yeah, this is just like intuitively, like first you pick 1 from 25, then you pick 1 from 24, then you pick 1 from 23, done. Suppose a sorter transmits a message consisting of bits with a probability p that the bits received correctly, hence a probability 1 minus p the bits incorrectly received. The message consists of 10 bits, and p is equal to 0.95. What's the probability of the message containing exactly 2 errors? Okay, so now they're going to talk about these things. So, yeah, what they're saying here is the chance of one singular bit being transmitted correctly or incorrectly is a Bernoulli distribution. And the Bernoulli distribution is the most boring type of distribution there is. It's basically, you do something that has a chance to succeed. It's 1 if it happens, it's 0 if it doesn't happen. Like, those are the only 2 options. It's amazing, but it's boring. But it's amazing.
I always remember that a binomial
true cause of
distribution
two.
is a sum of Bernoulli distributions. Or like a whole bunch of Bernoulli distributions.
Okay. A message consists of 10 bits, probability, blah blah blah, a bit is transmitted correctly. What is the probability that it contains exactly 2 errors? Now we're talking about binomial distributions. I really like these because these are like, at least to me, intuitive, and they allow you to do quite complex things. So what it does here is you want to know the chance of, for example, k different. Okay, like, I should come up with a concrete example, otherwise I'm just repeating the formula. Say I want to I flip a coin 10 times, and I want to know the probability that 3 of them are head. In that case, n, the total number of throws is 10. K, the number I want to have is 3, and p, the probability is 0.5. And then what the formula is intuitively asking is, I want to have 3 times heads, then I want to have the rest, so in this case 7 times tails, and then I want to see in how many ways, that's this thing, the coefficient, in how many ways can I arrange those two. So heads, 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 tails, 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 heads, heads, tails, heads, tails, 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 etc. So that's what this formula really means. And let's see.
Yeah.
Here we have a binomial distribution. You will notice that it is that it's always symmetrical across this this boundary because again the only thing that really matters is wait. Let me see if what I'm saying is correct. Sorry, the coefficient is always symmetrical across half of k. So 8 over 3 is equal to 8 over 5.
Mm-hmm.
I'm not sure if that's also the case for the probability mass function itself. Either way.
Whatever, it doesn't matter too
Yeah, it
much.
doesn't matter too much. Next one. The geometric distribution means the chance of something happening, like something going wrong after first going right x times, or right after wrong x times. So again, what you're testing here is you're testing, say for example, in their example, we want to see if the fifth bit is sent with an error, and an error is 0.05. Then we want it first 4 times, so that's that k minus 1, it's 4 times it succeeds, so that is 1 minus it going wrong, and then it goes wrong. So then it would be 0.95 to the power 4 times 0.05. Yeah, because they're like all independent events, and you have, it goes right and right and right and right and wrong. So that would be 0.95, 0.95, 0.95, 0.95, 0.05. Okay. And then the last one, the Poisson distribution. I don't understand jack shit from that one.
Poisson. Okay. Poisson is basically it's weird. It goes up and then it goes down forever, but it can be like infinitely far out. But it like there's a most likely value, and then what you have is that you could have a million hits suddenly in 1 second on the website, or you can have 0, but it's likely going to be 3. That's the likely amount of time, likely amount of hits every second. So it's things that can happen. It's how many cars are passing on the road. There's probably going to be about 3 cars passing every minute. But you can have some ludicrous amount 1 minute and none the next.
Yeah.
They'll tell you what distribution it is. Cool.
Yeah, no, I see. No, but I mean, like, looking at this, that like, not looking at the formula, but like, and the way that it's a measure of time, I guess that kind of makes sense.
If you go to paint,
I know what it looks like. It looks like
Yeah.
like this, or like
Yeah.
The Poisson is just a measure randomness, basically.
Yeah, something like that, basically. Though it doesn't have the flat
Like a
part at the
normal
bottom.
distribution, but in discrete, kind of.
yeah. We'll see when we do examples about it, because like without an example, it's really concrete, complex to grasp. Let's continue. So let's see. We have a well shuffled deck, 1 by 1 until the table until the first ace appears. The number of cards until the first 8 is called X. The distribution of X is of the type. What do you guys think? Oh, no, that's kind of annoying. It's already giving the answer. Now my question is, why is this not a geometric distribution? Because we want it first to have not
The
an ace.
ends aren't independent. Geometric is only for independent.
What do you say?
They're not independent events.
Yeah, okay,
Like-
that makes sense. So the first one is like 1 out of 52, or 4 out of 52, and then it's 4 out of 51, and then it's 4 out of 50,
Yeah,
50,
exactly.
etc. So it would indeed be another one. That's a good call. Okay. Oh, Bog, what's the muddiest point? Muddiest point, Bog.
My life.
Okay, so I can close this. I can keep this open. I can get rid of this.
Get rid of me. You can't live without me.
Suppose you
0.
roll a dice and flip a coin. The number you throw with the dice does not influence whether the coin shows head or tail. Well, yeah. They are called independent events. Okay, makes sense. And sometimes we can be sure that the events are independent based on a given formula. In whether following case are we not sure whether the events are independent. Let's see. This one guarantees independence. So the chance of A and B happening is equal to the chance of A happening and the chance of B happening.
Second one, right?
The bottom
Yeah.
two are like the same thing, just worded differently. So
Yeah,
there's only one option left.
exactly. In this case, we cannot be sure because, let's see. We can prove independence if we can prove one of the following. Ah, so that's how they meant it. Well, yeah, this one implies independence by itself. And this one is the probability of B given A is equal to the probability of B. Yeah, that makes sense as well because then A does not influence B. And the probability of A given given B is equal to probability of A. Well, yeah, that's the same thing.
I still don't get why they state that twice. It's like the same thing.
They have to have four. So.
No, but like even in the answer.
True. B of A and B equals B of A, B of B. That is independence. Let's see. Two events are independent. Their intersection is empty.
False.
False.
Yeah, that doesn't have to be.
Because for that to be one of the probabilities has to be 0. If we're using the formula, if they're not disjoint.
Yeah.
Which they most likely aren't.
Yeah.
Because that would be very boring.
Yeah. True. You are given the following probabilities. So we have. Oh, I see. Okay. So how we're gonna do this is we have P of M given J equals 0.05. We have probability of M given J's complement is equal to 0.86. We have the probability of J is equal to 0.43. We have probability of J complement is 1 minus probability of J is equal to 0.57. We have probability of M union, so that is cup J. That's not true, that's cap.
That's cap.
That's not true. You saw what I did
No
there?
cap.
Cap J is equal to probability of M given J times probability of J is equal to let's see, is equal to 0.43.
0.0215.
Let's see, M mid J is 0.15. So again, let's check this. So this is equal to
0.015.
Oh, I messed up a negative sign here because of something. Yeah. Okay, so this is the probability of M and J. However, we are not given that these two events are independent, right?
No.
So we cannot use the formula like M and J is equal to M and J. That's sad.
No, but there is another formula. J and M plus J and not M is J.
Oh yeah. I see, yeah. And what you mean with that is let's see, cap J complement is equal to P M mid J complement times P of J complement is equal to 0.868 C dot 0.56 or 57, sorry, which is equal to 0.68 times 0.56 is equal to 0. Blah blah blah. Okay, so when we compile this, we will see what I mean. And then we have the probability of M is equal to the probability of M and J plus the probability of M and not J. That was really bad. Is equal to 0.0215 plus 0.3876. There we go. So let's see what's their answer. Let me actually put it there then.
The same thing we did.
Yeah, the same thing we did. Cool. Okay, that's a lot of numbers and a lot of symbols, but it's probably not that hard once we grasp the symbols. We know that a given
For
event.
this, drawing a probability tree always helps me.
Yeah.
For like when there's multiple first probabilities. Just to like have it organized, it helps me.
I mean, this one isn't too bad, honestly. So what it's saying is, we know that probability of W2 complement is equal to 0.67. Therefore, the probability of W2 is equal to 0.33. Let's see, anything else relevant? We know they're disjoint events, and we know that these are the only events in the sample
We
space.
also know a probability of W1, and therefore we can deduce probability of W3.
Yep. So we know probability of W1 is equal to 0.55. Probability of W3 is equal to 1 minus probability of W2 minus probability of W1 is equal to 0.12.
Yeah.
Okay, then let's see. Are we in any way, shape, or form able to deduce the probability? Well, yeah, we know the probability of A. Probability of A is equal to probability of A cap W1 plus probability of A cap W2 plus probability of A cap W3. So let me see. Yeah, so we know. Yeah, so we know this. So the probability of A is equal to probability of A and W1, A and W2, and A and W3. However, we can deduce those three probabilities by P of A is equal to P of A given W1 times P of W1 plus P of A. I am not using the right given sign.
Need.
Yeah, mead W2 times P of W2 plus P of A mid W3.
Oh, my brain's already fried. Love it.
We're only like 2 hours in. Isn't that fun? So, yeah, this is what we have to calculate, and we know all of this, right? So hell, we can end this into Graspel. So we know 0.19 times 0.55 plus 0.696 times 0.33 plus 0. What was the last one? 0.55. That's not true. 0.99 times 0.12. Let me see. This should be correct.
No, because we're calculating W2 given A, so that's probability of
Oh,
A.
this is A. Yeah, fuck.
Now you have to do A. Now you just have to use the formula. So
yeah, okay. Now, but this is easy
closest.
now. So we know P of W2 given A is equal to P of, or the fraction of P of W2 cap W, or cap A over P of A. And let me see if that's actually correct. I should add more new lines because this is turning out to be not very pretty. There we go. So then we have, we end up with, let's see, we have calculated this thing before. That's namely this thing. Yeah, because these two are interchangeable. So we can say this thing divided by this thing. That makes sense?
Silence is yes.
Hmm?
Silence is yes.
Cool.
Maybe check the dot between the thing on the top fraction. It looks a bit off. Yeah.
That could have fucked me over. I don't know. I don't know if it would, but it could have.
Shoulda,
Yeah.
coulda, woulda.
Yep.
Hätte, Fahrradkette.
Cool. I love these things where they just say, hey, you have this, you have this, you have this, calculate this. Give me that shit instead of the stupid fucking story type shit. Okay.
We're not here because we did wiskunde. Ah, godverdomme.
Yeah, this is Wiskunde, the Bay and Day gang. So we have.
If I wanted story time, I'd watch bad YouTubers.
If I want a story time, I'd watch Christoph.
Yeah.
Okay, so we have probability of Q is equal.
Imagine Christoph in like a math subject. Ooh.
P of G is equal to 0.82. Well, now we can calculate the probability of. Well, okay. Well, this is just easy, right? So we can have probability of Q gap G is equal to the. So this is both of them happening is equal to probability of Q mid G times probability of G is equal to 0.9 times 0.82.
They probably want to use like the formula and do it in one go, but like we can just do it like this and not have to remember the second formula.
There's second formula. Cool.
Yeah, there's one probability of A given B is probability of B given A times probability of A over probability of B.
Wow.
I think.
Did we have that yet?
Yeah.
Then I
So we-
completely read over that.
But, we can just do it this way. Have
Yeah,
like
no,
one extra step,
But
and not have
I
to
didn't
remember.
know that we had that. That's cool.
Yeah. I prefer doing the extra step instead of having to remember a formula. I probably said it wrong anyways.
What was the formula?
Probability of B given A is equal to probability A given B times probability of B over probability of A.
Have anyone
Yes.
here heard of that formula?
Yeah, no, that's correct. That's derived from the one we had in lecture 1.
Yeah, okay. So this
Yeah.
is just extra work, but
That-
it does work.
Yeah,
So now I can say
yeah.
P
Let's
of
just do this.
G
It's simpler to
mid
remember.
Q is equal to P of
Yeah.
or the fraction of P.
The
Yeah.
5 seconds this takes to do this takes longer to do isn't worth remembering another formula you might get wrong.
Exactly. Over P of Q. I forgot a new line. No. Like whenever I forget to add a new line, it makes everything look really daunting. Now we have this thing, and this is just equal to.
What is this? Quantum theory?
Yeah, we have actually had quantum theory, just not in this course.
What?
Yeah.
Well, not as in like university, but like me and my brother had it.
Yeah, same.
Yeah, same. Like touch. You also do physics, Armand?
Of course, I did physics HL.
Yeah. Which option?
Engineering physics.
We did what's it called? Astrophysics.
Let's
Yeah,
see,
that's
are
what,
these the right numbers?
That's what my
Yeah,
the rest of them did, but I didn't
Yeah.
bother joining
We
that.
didn't have a choice. We only did astrophysics. It was fun.
Nah, my teacher was cool. He was just, teacher was just, if you want to do something else, go ahead. Just do it on your own.
Oh god, this is like the same one we did just now. Pog.
Yeah. Again, they have a lot of deep questions.
Yeah, well that's good because that means less thinking.
Yeah. Less thinking, more
So again,
mindlessly writing things down.
Yeah, exactly. So we have this. We have P of V2 is equal to 0.34. I'm using shortcuts here. We have P of V3 is equal to 0.13. Is that correct? That makes 8. Does that make 8? No, that makes 9. That makes 10. Yeah. So there we go. That's correct. So then we have PB is equal to 0.53 times 0.09 plus 0.5 times 0.34 plus 0.86 times 0.13.
I know these questions are randomized, but having this before the other one would have been like a bit better for teaching it.
Yeah. All right. Well, this is still well done, so that means we're still on pace.
We're still only on base
Ooh,
theorem,
the
though.
challenging question. Honestly, like if this was just if the rest of the exam stuff was just like this, I can't see why it has such a low pass rate.
Well, but the rest is kind of.
Yeah, the rest is gonna be a lot
Also,
harder.
this exam is only half the grade.
Yeah, not only that, but this
Yeah,
is
but
like
if
this
you
is
Do we
hard
know
out.
what the average is of
something
this
like
exam?
a 9 or an 8 here, then you've basically passed the course.
Like, do we know what the average is of this exam?
We don't know the average. We do know the pass rate.
Yeah.
Yeah, but of this exam.
Last year there was no midterm.
Ah.
It was all single end term, which included everything in an hour and a half. So that must have sucked.
Yeah, the previous years also sucked for this
Yeah.
course. Like I was like,
They
oh,
basically have to do a
PTS was
reset.
better like the year before last year, right? Because of Corona. And they were like, not really. The year before last year had worse pass rates. The pass rate last year were 38.3, and they improved from the year before that. It was like 35 point something before that.
If your course has a low pass rate, I don't think that's the fault of the students anymore.
Yeah, like if it was like a 55 or something, a 35 is just kind of spit in our face. And the fact that they didn't improve.
Is that actually the pass rate of this course?
Yeah, the pass rate after resets is 38%.
What?
That's why I took 2
It's
days
fucking
for it.
Probability.
Well, yeah, but like only probability is like, and I don't. It's by the way, it's probability theory and statistics. But
And
yeah,
also they love putting in some really horrible questions on the exam.
yeah, you've done it before, right? So,
No,
you
I
would know.
haven't.
oh wait, then I'm confusing you with the other dude here.
Yeah, I mean,
Yeah.
yeah, exams are horrible. But this first midterm is really isn't that bad. It's just end term.
Yeah, I'm not looking forward to the end term. But we'll see.
As long
I
as
mean, yeah.
as long as we get like a 9 for the midterm.
Exactly. There's no minimum on either, right? So if we get like a 9 here, then we can just get a 2 there and be done with it, or a 3.
There's no minimum. There's a minimum of 5, right?
Fuck.
There's
No.
No, it's
I
not.
think there's a minimum of 5.
Yeah, there's
or
a
they-
minimum of 5 for both.
They probably just forgot
Wrong.
to mention.
My teacher explicitly told me there is no minimum. You can get a fucking 1 for one and a 10 for the other and pass.
That's a joke. That's
There's no way
okay.
that-
I'm gonna pass this year. Hallelujah.
Well, I don't think they would joke about that.
It's literally.
No,
not
somebody send a
possible.
fucking email, guys. It's not hard. Let's continue.
Sending emails? Nah, we don't do that here.
Well, you can also just ask your teacher next time you have the course. Do we have the course tomorrow? No, right?
We have the course on
No,
Monday.
no, we
The
don't.
only question is, will we get a response before the midterm?
You know what? I'm gonna get the slides. This is like something
Why
I would have
would you
taken a
need
screenshot
them?
of.
Why would you need a response before the midterm? How is that going to change what you're going to study for?
It depends how hard you're going to study, but no.
I
Yeah.
think
the
you
PU
study
is
really hard
20.
in any case.
Here.
This is interesting. PU, given that C complement is equal to PU. What does this imply? Does it imply that C is equal, like the C's complement is equal to 0 and C is equal to 1?
I've sent the screenshot in the thing.
probability of U given C complement is equal to the probability of U.
Yeah.
That means they're independent.
Okay.
It's PU plus PC minus 2 times P times PU times PC.
It means that PU that means that fucking
So in this case, PU given C complement is equal to PU, and PU given C equal to PU are both the same thing, and they both mean just that they're independent.
Yeah. So we just have
Ja,
to
we
do-
zijn bezig met les, we kunnen niet. They're offering us garlic bread, but we have lessons.
but that
Ah.
remember the PU and C complement the A given B formula.
Yeah, but what this basically means is if they're independent, we know that P U cap C is equal to P C times PU is equal to 0.2 times 0.20. What's that, 0.04 or something?
0.004.
But it's union, it's not and. No, it's not. Or
Yeah, but we need that to calculate the union.
Exactly.
yeah.
I'm not gonna fill
Yeah,
this in. It's just that
Yeah,
like
yeah,
I
well,
wanted to
I
know.
guess that's also another way. Yeah, that one is correct to calculate.
Yeah, and then we
this
get
out.
P of U cap C, or
I was just thinking.
cap C is equal to P of U plus P of C minus 2 times P of, or actually,
Mm,
not 2
one
times. It's
times.
minus. Yeah, minus 1 time. So minus P U cap C is equal to 0.22 minus 0.004 is equal to 0.21 and 6. Did I copy enough zeros for the 004? Yeah, I did. Check my answer. What? They rounded it off?
Yeah.
They probably didn't even expect you to put a decimal. They probably just expect you to put x plus y minus z in.
Yeah, no, but like if they rounded it off, then the true answer would have just been PU plus PC. Like this term doesn't add anything. So you could have gotten the wrong thing and still gotten it correct. That's so annoying. Oh. Okay, story time, guys. Fun stuff. Charlie is building a camera drone that flies around and that flies on its own and keeps
And
track
bombs
of the
Iraq.
That bombs Palestine.
He's not part of the U.S. defense. So,
Seriously though, free Palestine.
free Palestine.
Yeah, free Palestine.
Cool. So we have.
Where can I get it?
Fuck off. Free Palestine. Where can I get it? Punk. Okay. A is the alarm goes off. F is the drone flies far away. Probability of the drone flying too far away is 0.04. So we know this is equal to, or 0.24. Sorry. And the probability that that the alarm goes off when the drone is actually flying too far away. So P of,
Oh yeah, never mind. You changed it.
P of A mid F is equal to 0.88. That's 88. Okay. Does it still have auto recompile on? I think it does, yeah. There's probability of 8% that the alarm goes off without a reason. So that is probability of A mid F complement.
Why do they give us the thing and then give us the thing again in more clear language? Like,
Yeah. I mean, I don't
Just the
mind,
numbers.
honestly, you know. Take the W. What's the probability that the alarm goes off? Well, this is easy because like right now we have. Yeah, okay. So I'm gonna write down a few formulas. So we have A of A cup. No, A cap F is equal to P of A mid F times P of F. And we also know that P of A is equal to P of A
you forgot the
Gap.
new line again.
F. Yep. There's probably a better way to do this than this way, but I'm very bad at anything. P of F plus P of A cap F complement times P of F complement. So this is the formula we're eventually going to be going to end up using. So let's enter that. And we know again that like this is equal to that. So this ends up being very big formula that's very fun to enter. P of A mid F times P of. This is incorrect, by the way. This should be P mid F.
Yeah.
Because the chance of A happening is a chance of A happening and F not happening, and the chance of A happening and F happening. And again, the chance of A and F happening is again chance of A given at F times the chance of F. Cool. So we know almost all of these. So that is 0.24 times 0.88 plus 0.08 times 0. What's that? 76?
6.
Like this?
Yeah.
Check. Alright. We're getting... I like these exercises. They're getting more, like... As we do more of them, I'm getting a true more understanding and, like, better fluency with the material. I haven't had that with some of the other ones, so...
It's almost like they're learning.
Yeah, no, we're actually learning. That's, like, insane, right? Okay, let's see. This one is interesting. So we have PA given C is equal to PA and C over PC. I think that's always the case, so that's not true.
Yeah.
P of B given A is equal to PB times PA. Oh yeah, this is the second one is correct. So that's P and
Yeah, I love how they just
yeah. So what this really
Trick you.
means is they're doing
PB is
PB given A is equal to PB and A over 1 minus PA complement, which is PA. That's the general formula. However, in this case, you can see that they didn't actually use PA and B. They used PA times PB. But because this is equal to PA and B, we know that they are independent. There we go. Next. You're given two events that are based during a fair dice twice. Event A has 3 outcomes, event B has things outcomes, and event of A given B is equal to 2 over 11. Well, that's really, really easy to check. So wait, I'm gonna actually zoom in on here.
to be
and
equal to
zoom
probability
out
of A,
here.
so has to be
Okay.
equal to probability of A.
Guys, if we finish this early, we gotta play some keep talking and nobody explodes together.
Trust me, I hold 7 world records.
Damn, son.
He's
Yeah.
also the moderator of the thing. It's really
Yes.
cool.
But like fucking, if we're done early, I'm afraid instead we're gonna do the exercises, the Python ones.
Yeah, probably.
Ugh.
P of
Boring people.
B equal. So when you're talking about 11 outcomes, you throw a fair dice twice. That's 11 out of 36, right? Yeah, I think so. Okay, that makes sense. So now we have to check if P of A mid B is equal to fraction of P of A and B over P of B. Well, we know that this is always correct, right? But the thing we now have to figure out is if this is equal to let me copy this. Instead of A time or like and B, A times B. So if these two are equal, then we know they're independent. So let's fill this in. That will give us the fraction of 3 out of 36 times 11 out of 36. Oh. Over 11 out of 36.
It's just PA.
Yeah, but that would just need be PA, but this is not equal to PA, so therefore they're independent. Or they are dependent. Because that means that this thing is not equal to this thing. So the statement is false. Yeah, which is 3 equals 36. So yeah. Cool. Let's see what's next.
Diabetes test again.
Ooh. Something actually interesting. Poggers. So let's see. Bunch of text. That's not really the interesting part, but you get what I mean. So we have. So we know that PA given B is equal to P not P not A given P not B is equal to P. I hated the fact that they use P and P for probability. Because I'm not gonna say capital P every time.
It's just called a little p row for simplicity because Greek letter.
True, might do that. We'll see. So let's see.
Then you don't get the opportunity to say PP.
Oh, that's true. That's P of P. PP.
Yeah.
Earlier research showed that the blood sugar level of 6% of the population actually exceeds the threshold.
PB's point.
Yeah, so we know that P of B is equal to 0.06. let's see, what else do we know? That's the only information we know, other than that PA given B is equal to PA. Yeah, okay, but I can work with it. I can work with this.
PB given A, we want that to be 0.95, so we need
Yeah,
to get a P that agrees with that.
yeah. So what we can do now is we can get P of B complement is equal to 0.94. Then we can get P of A and B is equal to P of A given B times P of B is equal to P times 0.06. The probability of A complement and B complement is equal to let's see, it's equal to the chance of A complement mid B complement times P of B complement is equal to 0.96. This is incorrect, by the way. So this is equal to P. 0 for Y is equal to P.
Why?
No, wait,
it...
that's not correct. That's
no,
not true.
You were right.
I was
before.
right. I was right.
Yeah.
So we know that A and B, and not A and not B, are these two values. Let's see. And we also know that P of B given A is equal to this. Well, now that's actually not too hard to calculate, because we know P B given A is equal to the fraction of P and A, sorry, P of B and A, over P of A. Yeah, that's correct. Which is equal to the fraction of B and A. So yeah, that's the same as A and B. So that's 0.6p, 0.06p over P of A is equal to 0.95. However, we don't have anything for A in terms of P, so we're gonna have to figure that one out. Well, actually, we know A and B, and we know B, so we can get A from that. Is that correct? No, we also need A or B for that, right?
A or B is just 1 minus not A and not B, because
yes, because you can use complement rule there. Good call, good call. So let's say P A cup B is equal to 1 minus P A complement cap B complement is equal to 1 minus 0.94p. Okay, therefore we can conclude that P of A is equal to P of A and B minus P of B plus P of A or B. I forgot a new line here. And this formula I just pulled out of my ass by looking at this thing. So we want to know this thing, that's equal to this whole thing minus this thing plus this tiny thing. I did these ones the other way around, but it's still correct. So it's what I did here, like this thing minus this thing plus the whole thing. So it would make more sense to flip it around, but this thing here is correct. Yeah, you can check that by subtracting like these two to the other side. That will get P of A or B is equal to PB plus PA minus PA or A and B.
Ammon, come on.
What?
What?
During trying to study playing Stellaris, seriously.
Bro, I was playing KSP earlier. Do you think I study seriously?
Let's continue. So we want to fill this in. So this is equal to, and I'm gonna make a new line here. So we have a cap B is equal to 0.06 P. Then we do we subtract P of B, which is 0.06, and then we add P of A cup B, which is 1 minus 0.0 plus 1 minus 0.94 P. And this will end up being equal to minus 0.88 P plus 0.94. And let me check if that's correct real quick. Oh, and the new line, obviously. Okay. So, we have P of A is equal to P A and B, which is equal to 0.06P, yep. Minus P of B. P of B is 0.06, yep. Plus P of A or B, which is equal to 1 minus 94P, yep. So this is correct. And then this minus that, that's this, correct. This minus that, that's this, correct. So this is correct. And what we do then is we, this is P of A. So we can fill that into our formula here. And we know that, yeah, okay. So this is everything we need really. Oh, I have copied an extra equal sign. So knowing this, we can just solve this by multiplying the left and right side by the bottom of the fraction. Will leave us with this. Multiplying out the brackets will give. Why can we not work with bigger numbers? We can work with bigger numbers.
Multiply everything by 100.
Exactly. So this will be 6.
Yeah, you can just do that.
And this will be 95. However, I can only distribute that 100 to one of the two here. Unless I multiply by 100 again. Haha! 600.
Ah!
Minus 88 plus 94. Okay, cool. This did not make anything significantly easier. However, I'm going to say it does so that I feel good about myself. So we have 600p is equal to, grab my calculator anyways. So this is 95 times 88. So that becomes
A nice big number.
a nice big number, exactly. And then we do minus this thing times p plus, and then we get 95 times 94.
Another beautiful number.
Oh, another really big number. Poggers, guys. Poggers in the chat. Then we subtract this number from both sides. Oh, wrong one. Then we add this number to both sides. So then we get, let me actually,
It's 8360, so you get 8960.
yep, so that is 8960. P is equal to this number. Therefore, P is equal to the fraction of 8930 over 8960.
Yeah.
Did anyone spot any mistakes during the way?
Not really.
Because we're still on the way to green percent, but that might change soon. Let's see. The fact that they say use 4 decimals does give me hope. No fucking way we got that correct. No fucking way we got that correct.
I mean, it was less than 1, so.
Well, yeah, true. Oh wow, they calculated it differently in a probably easier way, but ours worked as well.
And that's what
Wha-
matters.
Exactly.
Why do it smart when you can just brute force it?
Exactly. Why say many word when few word make do?
Do trick.
Ah, yeah. How far is this the end of lecture 2 yet? No.
No.
Okay, yeah.
Actually, yeah, because it shows you all the now.
Oh
basic,
yeah, there's different things for all the
average
distributions as well.
Yeah.
Okay, that makes sense.
But these
we
should
might
be a
not
little
be.
faster.
A random variable is 1, the outcome of an experiment, 2, a function which converts the outcome of an experiment into a real number, and 3, a randomly generated number. Well, you know, a random variable is 2. Yep. Okay. The random variable can only take the following values. So the random variable itself can be anything.
Equal or related to the outcomes of an experiment.
Yep. The rest is just that makes sense. I can say
Okay.
like a random variable, and namely I throw a die and I multiply that number by 100. That's the random variable, but it's certainly not negative. It's certainly not the value between 0 and 100. It's certainly not 0 and 1.
And it's also not a direct outcome because that would just be 1 to 6, not
exactly
1 to 100, 600.
The probability mass function PA of a discrete random variable is defined by, and be careful here it says mass function, so it's not a distribution function, so it's only that specific point. If we had the probability density function, that would be f of a, which would be equal to...
It's a distribution function for discrete variables, isn't it?
Hmm?
Wasn't density for continuous?
Sorry, it's a distribution function.
Yeah, I hate the fact that they gave those names starting with a D.
Exactly! Okay. Suppose you have a discrete random variable that takes on values with a specified domain. Within this domain, a discrete random variable can take a number of values. It can take an infinite number of values.
No.
No.
The input space can be
It's
infinite.
discrete.
Oh!
No.
Yeah, okay. And, like, there's an...
You can't map 1 onto 2. Like 1 onto 2 different values.
Yeah, and it's like, it's a discrete random... So there's like... So this thing only has, like, 37 different values it can take. So... Yeah, there's only a finite number of things, and you can't get 2 outputs for 1 input, so...
You can take as many values as it wants, just not infinite. You can have like 100.
What do you say?
It doesn't have to be just 37 values. It can be like 200 values. The point is
Yeah, it can be like 10 to the power 100, but it doesn't matter because it's not infinite.
Yeah, exactly.
Yeah, 10 to the power 100 is still like impeccably tiny when compared to infinity.
Conrad, I think Stellaris listened to you and it crashed when I opened it.
Okay, a random variable is, well, didn't we just... The more you know. Hey,
yeah,
it's still green percent, right?
Stuff all the
Still
time.
green percent.
Still green. Yep.
I'm always so curious to see how far we can go, like doing green percent. Practice now. Yeah, okay, this is not too hard. So we have b and the probability of b. And it's a discrete random variable, so again, like it doesn't have, because these are the values given, there are no different values. And we know that f of b is equal to, so let's see, f of 12 is equal to p is of x is less than or equal to 12 is equal to, well then just all the numbers up to and including the ones that come out of 12. You guys understand that? Cool. Next. You would like to have a statistical model for the amount of beer measured in the number of the bottles sold during the day. It perfectly fits the data he
Who goes
collected.
to a cafe to buy beer?
Hey,
Who are very, very rich or very, very poor. There's no in between.
Like,
don't question his life choices.
What do you mean it's great? Cafes.
at least go to a bar. Like,
What if it's 5 p.m.?
What if it's 5 a.m.?
What if it's 2 p.m. and you just want 1 beer, huh? Don't go to a bar for that.
Okay, but why would you go to a bar for 1 beer anyways?
Exactly, go to a cafe.
Either way, the distribution Peter found is most likely, well, it's not discrete, because, well, actually,
That sounds very much discrete.
it's not continuous because,
Yeah,
oh,
if it's
wait.
not discontinuous, it's discrete. Dot.
Yeah, because the uniform distribution is also continuous.
You can have a uniform, like, discrete distribution, but that's just
Yeah,
a very
and, like,
boring
He
distribution.
took discrete data, namely the number of bottles. So
Yeah.
yeah, you can't just magically make a continuous function out of that. Well, you can, but you get the point.
those like people who slice like bottles with katanas.
Based.
Yeah.
Okay. Oh, Pog. There is no value of 12, so the answer is 0 because the chance of
Yeah,
B.
there's no value less than or equal to 12, so it's 0. If
Yeah,
it was
so
like
it's
if
not
the first
0.
value is 5, the second was 75, it would be 0.29 still, because everything less than 12 is.
Exactly. There is no value less than 12 for which it is not 0. Let's say it like that.
Yeah.
Okay. Next. Which of the following is not a discrete random variable? A dispensed number of particles is discrete. A dispensed volume of liquid.
It's continuous. That's continuous.
Number of
Yeah.
brushes is a discrete,
Yeah.
and the error count is concrete. A discrete.
Yeah. Can I have like infinite?
Just think, would you use more or a higher number or whatever the fuck it is in English,
Yeah.
or much for many? That was it. Much for many.
Yep.
Yeah.
Okay.
A lot
Much
of.
liquid, many pieces.
Following
never,
function
like-
is given. We want to determine a probability mass function. Well. Oh. Okay. Yeah. So now they're
It's
asking
just,
for the P, not the F, and this is quite easy.
Yeah.
0.1.
No, it's 0.1. Oh yeah, this is 1. So what they're asking is like, the sum of everything is this. The sum of everything now is this. So this jump here is the probability of this thing at 86.
Why didn't the table change colors?
Okay, we have discrete random variable x, and y is not a discrete random variable where y is equal to 0.5 x to the power 4. X has the probability mass function p, blah. What is the value of the distribution function y at 0.15? So let's see. Let me make a quick table for that. And again, we cannot, like, at first I wanted to take these numbers and fuck with them, like make it 0.5 times 1/5 to the power 4. Doesn't work because all these chances have to add up to 100. So the things we have to fuck with are these. Do we though? Because let me think about that. Because in this case, if we have 0.5 x to the power 4, or x to the power 4 of 2 and -2, both are, let's see, 2, 4, that's 16. So 16 would have a probability of 2/5. Then 6, well, that's 6 to the power 4, 36 squared times half, 16 times, times 32. No, that's not true. 18 times 36. That has a chance of 3 out of 10. And this thing has a chance of, what would this be?
Not 8? Oh yeah, never mind.
A high has a chance of 3 out of 10. However, we care about A is 15, which is smaller than both of these numbers. So at that point, the distribution function value is still 0.
Yeah. Also, no, it's not this. What?
Oh! A half times. So it's 2 out of 5. Yeah. I fucked up my half times. So.
Instead of being smarter together, we're just the same stupid, just more people at once.
There's more people being stupid.
Apes together might be strong, but apes together also stupid.
Well, yeah, but we can use intelligence, but you can also use brute force. Me at any CTF problem ever. Let's see. So we have this. This distribution function, and now we want to calculate. I see. So what they're doing here is FB for any B bigger than this number, or then 1000 is what we want to calculate. Let's see. Let me see if I can find a way to put this into words. So we have f p of x is bigger than of geku 1000. Let me see if that's actually the correct thing to say. Yes. Which is equal to 1 minus p of x less than
Lek.
1000. But because it's a discrete... Oh. Let me
You just have to use the symbol on your keyboard. There isn't a less than E symbol in LaTeX.
Is there not? Okay.
I don't think there is, yeah.
No,
And
there
I
isn't.
checked. I want to check it once, but there isn't.
And
Which is
because
really
it's a
annoying.
because that's a discrete random variable, we can say that this is x less than or equal to 999. Because again, they only come at finite intervals.
That's 0.52 then?
So let's see. And this is actually equal to 1 minus p f of 999. So that might, I think that's this number then. Would that be correct? Like, does that
1
make
minus
sense?
that.
Let me ask it like that.
Would make sense, but I'm not quite sure.
Fair, we'll see.
But we haven't been taught. No, 1 minus that.
Hmm?
1 minus that.
Yep, good call.
Yeah.
Nice.
Yeah, because they haven't taught us about cumulative frequency at this point. So
Yeah. Also, I fucked up. It's not. Oh yeah, so it's less than 1000.
Yeah.
So yeah, okay. So that's what I had. Cool.
for discrete, it doesn't really matter because anything less than 1000 is 999 or less. It's
Yeah.
the same.
Like,
For continuous, it would be different.
yeah, but even then, like this is true. However, I always put it in this form because it's actually f of 999. Like if you were to take this and then say this is equal to f of 1000, it wouldn't be correct. I mean, in this case it would be, but that's because f of 1000 equals f to 999.
Yeah.
You get what I mean. Next.
Mhm.
Let f denote the corresponding distribution function and determine f of this thing. Well, that's not too hard, right? That's just 0.5 plus 0.24 plus 0.12 plus 0.08.
No. Oh yeah, it's 40,000 or 4,000.
Yeah, so that is between these two numbers.
Yeah.
Therefore, yes.
They give it way more complicated than they should.
Yeah, way more.
Oh, it's the
and then
same
we have this
question
one. Ooh, this one.
It's the exact same question again.
It's almost as if it's 2/5.
Yeah. Just a guess though.
Just a guess. I'm just very, very good at guessing.
Still green percent. Still green percent.
Still green percent. I swear to God, one of these is going to be the end of me, especially when we have to do poisson. Bernoulli, Benami, poisson.
I don't think they're gonna ask us poisson.
I want to have some poisson.
Pure poison.
Are you going to finish that poisson?
We need some poisson.
Jimmy-kun, are you going to finish that poisson?
Poisson.
Ah, I'm going to drop my croissant.
Hey, the poisson
distribution.
distribution.
Okay, whew. There are two independent events G and Q. Probability of winning event G is 0.018. Probability if winning event Q is 0.013. R is defined as the number of times you participate in the event until winning at least once. Random variable R is a geometric distribution with parameter. Okay, so basically
exponential.
what they're saying, and this is nice because they already gave us a big part of the answer. PR is equal to PG PQ plus PG1 minus PQ. And oh, I'm using capital, should be lower.
Oh, geometric. Yeah, that was it.
Yeah, and this makes sense when you think about it, right? Because either you win both, or you win one and not the other, or you win one, the other and not one. So this is what they're saying. and we are working with a geometric distribution. So therefore, when we have that, the function is p of x is equal to, or p of x is equal to p times 1 minus p to the power of x. Or let's say k. X is equal to k is equal to this. So let me make a new line here and then recompile. You guys can see what I mean. Yep. And then we know that the probability of r is equal to this probability. And because this is actually, we are working with random variable r, so I made a mistake. I should have said it like this. And we want to know the probability of winning the prize the first time we play. So what we're interested in, we are interested in p r is equal to 1 is equal to p 1 minus p is equal to this thing times 1 minus that thing. Well, let's first calculate p. In this case, this will be pr, by the way, because we are working with random variable r. Okay, so we have 0.018 c dot 0.013 plus 0.018 1 minus 0.013 plus 0.013 1 minus 0.018, and then this thing times 1 minus that thing.
Isn't it k minus 1?
Hmm?
In the second line, should it be k minus
Oh,
1?
you're very much right. Good call, good call. Thank you. Yeah, because you know the thing on the pay on the left is actually also the one we want. However, that means that yeah, this k minus 1 will just turn to 0 when we have k equals 1. So then this is just equal to PR. So I can get rid of this, and therefore this is the answer. Yep, seems correct. Nice. Good catch, good catch. I would have not seen that. You are tossing a coin. The probability to get a head after each flip is P. You decide if you toss okay, sentence long. You come in. Ooh, thank you very nicely.
Thank you very nicely.
Oké. Jelle, kom even. Ja, moet je even de kabel ook meenemen. Jelle, kom even.
Nee.
Oké.
Hoezo?
I have garlic bread.
Oh.
Oeh.
Jelle is kneus op nu.
Misschien zo. Ik zet een potje rijkt.
Ah, okay. Anyway, guys, if you hear me chewing throughout, I have garlic bread. So,
Oh, lucky fucking bastard.
exactly.
I'm dead.
You're tossing a coin. The probability to get heads after each flip is P. Hopefully a half. You decide that if you toss the coin and turn out to be tails, not heads, you toss the coin again. If it turns out to be tails again, you toss it. You fucker. It does the third time. The experiment, the entire process of flipping the coin 1 to 3 times, consider one Bernoulli trial, where each trial has a probability of 1 minus p cubed of showing heads. You decide to define the total number of heads that you toss after n of such Bernoulli trials to be x. Distribution of x, total number of heads that you toss, is called a x distribution. Okay, really everything in the start,
like n Bernoulli binomial.
Exactly. This is not interesting. I literally forgot everything. You decide to define the total number of heads that you toss after n of such Bernoulli trials to be x. So basically, what it's saying, you have something with probability p, and the chance of, and you want to know after n trials how many or what's the chance of having x things with probability p, binomial. Do you guys understand that? Again, by the definition of a binomial. So, yeah. I see. So here we have. We're betting on horse races. We have probability of winning PA of town A, PB and town B. Once we win, we stop. So what we're doing there is we are doing something with some probability calculated from PA and PB. We're doing that times until we stop. What is that? A geometric distribution. There we go. Okay, this one is interesting. So, we throw the coin until we throw heads a second time. And X is the number of times you throw the coin.
So there's two possibilities: heads, tails, sets, or tails, heads, heads.
Yeah. So that is actually. So we have P times P times. Let's see. Throwing heads is actually okay. That's my bad. So it's P times P minus 1 times P, or P minus 1 times P times P. Because as you can see, like this is heads, so we either have heads, tails, heads, or heads, tails, tails.
Yeah.
And again, because these two are actually equal, and these are independent like possibilities, we can add them. So all of this does is equal to.
We could simplify this to a binomial distribution.
Yeah, definitely. This is a binomial distribution actually.
Yeah.
So this is 2p squared 1 minus p, or p minus 1. No, actually it's 1 minus p. My bad. So it's 2p squared times 1 minus p.
Principle.
Same principle, but in this case it's really fucking easy. Because they're saying we have a probability P that you throw heads. What is the chance that you've thrown 2 heads in 2 throws? Namely, what is the chance that you throw heads twice in a row? That's 2 independent events. So it's the chance of throwing heads once times the chance of throwing heads once, which is p squared. Green percent, boys! Random variable x is binomially distributed, where n is 8, and p is this. Compute probability that there will be no failure during the first 13 rescue operations, but at least 1 failure during the 14 rescue operations. All lifeboats will be used. I can see that this is a challenging one. Let's see.
Too often, to be honest. So
it's 13 times.
13 times 8 in a row. It goes well, and then it's just one.
Okay,
failure.
so here it says actually no failure. I didn't see that. So
yeah,
indeed. So they're asking really 13 times. It goes well all the time, and then there is 1 or at least 1 failure during the 14th. Yep. So basically, we can say, we can first calculate. Let's say P of E is equal to all of them functioning is equal to. That doesn't work, but you guys know what I mean when you see this. PE all of them functioning is equal to.
If we finish in time, can we do a instead of doing the exercises which are only to help you get a small intuition, which we already have, can we do some previous exams, or are they not online?
I think they are probably online.
We're
however,
not gonna You're not gonna finish this today.
No, I know. I'm just saying that if we do this in 2 days and we finish it in this first half, the second day, we might as well do an exam, you know?
Yeah. True.
Yeah, sorry, continue.
No, but that's yeah, we'll have to see, like, because this is the first time that they actually divided the exam into 2 parts, so we'll see. Either way, so the chance of all of them functioning during one trial is equal to 1 minus this, which is the chance of one of them working properly, to the power of 8. So you want all of them independently to work. Okay? So that's the chance of all of them functioning during one trial. We want the chance of all of them functioning during 13 consecutive trials. So then we'll get 1 minus 0.0102 to the power 8 to the power 13. I don't understand. Honestly understandable. Okay. So let me add another set of brackets. Okay, so far so good. That is, I forgot my my brackets here. So far so good. So this is the chance of all of them functioning during the last one. Now we want the chance of one of them failing during the last one. So then we multiply this whole thing by 1 minus the chance of all of them functioning. So again, the chance of at least one of them failing is equal to 1 minus the chance of all of them succeeding. Let me do some little bit of simplification. So this becomes to the power of 104. I'll add a C dot here. I don't think there's much else to do here for when it comes to simplification. Oh, and 104 should be. Okay, I think this is correct. Nice. All right. Yeah, and they're using here the px is equal to 0, something over 0 is equal to 1, something to the power 0 is equal to 1. So this is indeed just 1 minus this thing.
Hey.
This one isn't too hard.
Isn't this exactly the same?
Oh, it says none of them. Oh, pog. Absolutely poggers. I'm gonna add like 8 to this one, and this is the answer. The only thing is different because I'm
And it's 7. No.
and P is different.
Yeah.
So this is 0057, and this is 7 to the power times 14. I'm actually
Don't forget your C dot 1 minus stuff.
no, there's no
No?
C dot.
Oh yeah, none
They
of them.
only
Okay.
ask, yeah,
Really?
they don't ask for, and then it fails. They just ask it. None of them failed during these. Ja. Die stoppen we in het zakje. Pi? Okay, cool. You're tossing a coin. The probability to get head after each flip is P. You decide that if you toss the coin and turn it out to be tails, not heads, you toss the coin again. There's be tails, turn it toss it a third time. This thing is considered a Bernoulli trial. You decide to define the total numbers of heads that you toss after n of such Bernoulli trials to be x. It's a binomial distribution with parameter n and pi, where pi is the probability of tossing heads in each trial. What is the value for parameter pi for this distribution?
So
You
what's the
toss up-
probability of tossing head? Of tossing head in this weird ass thing, which is honestly just the best way to do it. I would make a tree.
Yeah, that's what I would do too. So we have either the chance of throwing heads or tails plus heads or tails plus heads. Those are the only three options. Let me add new lines. So these are the only three options that is possible. Now, then there's no. Actually, that's not true. There's one more. So these are the four options that are possible, and the probability that we throw at least one head is actually equal to 1 minus the probability that we throw three tails, right?
Or just the all three
Or all three added up.
Or
Those
all other three added up.
Yeah, correct.
Yeah.
Those are two. Those are both correct ways.
So 1 minus no head.
Wow, that was bad. So we get 1 minus no head to the power 3. Well, that's pi. That's it, right?
Well, hold on.
Hold on.
Oh yeah. No. My dumb ass was about to say no. Just fill in 3/4 because it's a coin. It's 50%.
Give it into. Actually, Yella, I have a better idea because I asked for pi. What if I just say 3.14?
Ah! 3.14159.265.
Plus 0p.
Plus 2 kp.
Met kaas 0.
Yeah. Also, I heard somebody saying 3.1405926525897932384666433823795.
Oh, there you go.
Yeah, been there.
Yeah.
ADHD kid during lunch
Haha.
break with nothing to do.
So funny.
While you were busy memorizing pi, I calculated Fibonacci as fast as possible.
While you were busy calculating pi, I studied the blade.
While you were calculating Fibonacci as far as possible, I went outside and touched some grass. Jesus Christ.
Jesus.
No, that was when I was done with tests early.
While you guys were socially competent, I was just existing.
Yeah, we did too.
Technically correct.
Yeah.
Let's continue.
Suppose a dairy factory produces a fuck ton of milk. Sometimes a certain step in the process goes wrong, resulting in an unsafe milk carton. This always happens independently.
Oh no! The milk carton is
Milk-related
gonna kill us
accident.
all!
This always happens
Milk-related
independently and does
accident.
not affect all the other cartons. The factory needs to ensure that all the cartons are safe and suitable for consumption. The random variable x denotes the number of unsafe cartons collected before selling, and the milk selling
The
milk
way they
and P
word it
unsafe.
sounds like- The way they word it sounds like you're eating the cartons.
No, to me it sounds like the cartons are out to kill ya.
Yeah, that too. Given an expression for P, give an exact number without rounded numbers. Okay, interesting. Oh, okay. So they're just asking us to give latex binomial coefficient.
Yeah, / no, it's / binom nk. You can just do that.
No, because then I have to import asmat.
Okay.
Either way, let's see if this works. So we know that p x equals k is equal to. So we have n choose k times p to the power k times 1 minus p to the power of n minus k. Let's see if this compiles. Oh, it does. Oh, it looks pretty. Pogers, dude. Yeah. Okay, so this makes sense, right? Because again, as I said, we have P successful trials, N or K successful trials, N minus K unsuccessful trials, and N choose K different ways to to simulate that. So what we will then do for P x equals, oh, it should be capital X here, x equals to 8, we have K is equal to 8. So what we do is we get 8 choose, that's not correct, sorry, 630,
N is 647.
yeah, that choose A times 0.0170 to the power of 8 times, I'll seal this bitch, times 1 minus 0.0170 to the power of
639.
639. And I should use these things here. Okay. And now, because I'm not sure if it will understand me saying choose, I will actually use the binomial coefficient. This one, and fill this in myself, but I will copy the rest. Yeah, that seems logical. Man, we're good. Woohoo! Wahoo!
Okay. Okay, that was scarily good.
Okay, there are 3 independent events A, B, and C. The probability of winning event, blah 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 blah. The random variable x is defined as the number of times you participate in the events until winning at least once. What is the parameter of the distribution of the random variable x?
By the way, that was supposed to sound like Toad, but it just sounded like a dying crow.
Yeah,
I don't even know what I was supposed to sound like, but I just made a sound.
fair. What is the parameter of the distribution of the random variable x? So that is the number of times you participate in the event until winning at least once. So that is basically all the events except for the ones where you win. Or, the number of times you participate in the events. So when you have a geometric distribution, which is obviously what this is, the thing that you pass is the chance that you do not win, right? Yeah. Okay. So the chance that you... No, wait. So it's the chance that you win. So when you have a distribution like that, what you actually do is you have p times 1 minus p to the power k. So this is what a geometric distribution is, in essence. So we want the chance that you win at either one of them.
K minus 1.
Oh yeah, I keep fucking that up, sorry. It's a really good one.
Yep.
Okay, so we want the chance that you win in one of the 3. So that is equal to, so I'll say p is equal to the chance that you win in A, and the chance that you win in B, and the chance that you win in C, or the chance that you win in A, but not in B, but in C, or the chance that you win in A, and the chance that you win in B, but not in C. Oh, I should do 1 minus here. C. Or the chance that you win in A, but not in B, but not in C. And then I copy all of this, I add this up, and I do the exact same thing, but instead of A, I invert A. Oh. So do you guys understand where I'm coming from with this?
No, but it looks hella ugly. But I understand it. But it looks hella ugly.
Oh, I fucked up my bracket somewhere. Ah, here. It should be a closing bracket. Yeah, so we're basically saying either you win all of them, or yeah. Oh, actually, I'm dumb. So this one should not be included. Because we don't want the case where you don't win any of them. So this is a chance you win all 3 of them, plus you win all 3 except for B, plus you win all 3 except for A, plus you win only A, plus you win B and C, plus you win only C, plus you win only B. Yeah, that seems correct. No way this is gonna go green. What?
Go green. Do.
What the fuck is that answer?
They collapsed the answer actually. They simplified.
No, I'm talking about yours.
Oh, yeah, well that's just easy. So, you see, the chance that we win one of the events
Oh yeah.
is equal to the chance that you win all 3, or the chance that you win 2 of them, or the chance that you win 1 of them. But because the events, the probabilities are different, we can't just say you win all 3, or you win 2 of them. You have to say the chance that you win 1 and 2 and not 3, 1 and 3 and not 2, and 1 and 2 and 3 and not 1. So you have to explicitly say all of that. Cool. Woo! Next subject. Bernoulli binomial geometric.
Couldn't you just set 1 minus the probability that you win all of them, or do you have to actually? You probably
Is
have
that
to
possible
actually.
actually?
I think it is.
Yeah.
Probably could have.
Hmm.
Yeah, I think, and
But
I think about it, that
this
probably
is
would have made sense.
Yeah, but this is probably better for explaining it.
Yeah. Oh no. Oh no.
Oh, no.
Give a number. Oh, so I have to actually calculate it. So it's like 27
31 times
factorial over. Actually, okay, so
31
it's n choose
factorial.
k, which is actually fuck it. We have formula sheet. M factorial over k factorial times n minus k factorial. So we have 31 factorial over 31
Just
factorial.
stop
times
runaway arguments, her.
4
No, 27 factorial times.
times 4 factorial. Okay.
Yeah.
So this is the answer. However, I actually have to calculate it for some godforsaken reason. So anyway, 31 factorial divided by 27 factorial times 4 factorial.
31 divided by 7 times 4.
I mean, you are allowed calculators, so.
Yeah, exactly. So this is good. Like we don't have to manually calculate that. Imagine having this
I mean, you
calculate.
could have done 31 times 30 times 29 times 28 over 1 times 3 times 4.
Mm-hmm. Anyways. What do we call this distribution?
Bernoulli.
Bernoulli.
And it burns, burns, burns.
The ring of fire. I think this notation is wrong. Is it not?
Yep. They should have small x, but
Yeah. Okay. So that makes sense.
Now to spell Bernoulli right, it's Bernoulli. It's on the formula sheet. No.
Bernoulli.
Bernoulli. Yeah.
Okay. Probability. We have a geometric distribution with parameter p. Probability mass function is given by. Well, that's not too bad. That's just p times 1 minus p to the power of k minus 1. We already used this formula 4 times.
Yeah, and it's on the formula sheet.
The binomial distribution is discrete. It will only take a finite number of values. So yeah, this is. I'm gonna be real with you guys. Discrete. From here on, it gets only what's it called? Continuous.
only
I don't know.
Continuous.
Is Poisson continuous? Yeah, right.
Or k equals 0, 1, 2.
Yeah.
Like,
K is continuous because
if you want to use factorial for a half, like you're gonna need the gamma function, and they're not ready for that yet.
Yeah. Okay. So this is still discrete.
Yeah.
Yeah.
So 1 to 4 is discrete, and 5 to 8 is continuous.
Yeah.
You can also
If
you
it's
can very easily see that because instead of saying
Yeah.
px is equal to this, you get small f of x and big f of x and well, I
if
mean,
it gives for k equals to 1, 2, 3, so on, it's discrete.
okay, cool. Let's go. A geometric distribution with parameter p is denoted as below for abbreviated notation. So that will be GOP.
GOP. GOP.
GOP.
This joke was made to you by the bad party.
Haha.
Now let's
Next
not
up.
bring it. Let's not bring politics into it. I respect both the Liberal Party and the idiots.
I mean, both are.
True.
Yeah, true.
The Liberal Party is literally center right.
Yeah.
Exactly.
Word left has lost its meaning. Anyways, let's continue.
The window has shifted.
Correct.
There is no room
left-
for intolerant in a tolerant society. Anyways,
Left is when people
Poisson.
complain, whereas right is when people complain over things that the left do.
okay. 2 assumptions about occurrent Poisson distributed events are independence and homogeneity. You see, the word homo is here, which I find very
I think
funny.
it's pretty funny.
Go.
If you
Thank you.
translate it from Latin, it means gay people are smart, which is true.
Homogeneity. It said homo and it said genius, so you know, gay people.
Yeah.
The question is interesting though.
Let's see. Homogeneity implies that the rate at which event occurs is.
I think constant, right?
Yeah.
Yeah.
Because it has a constant rate. Because the Poisson
Yeah.
was like
Yeah.
what
Otherwise, you
average
cannot
amount,
give
yada,
give a an argument if this wasn't the case, because then you'd have weird multiple numbers and stuff.
Yeah,
Hmm.
it'd be fucky. It'd be fucky.
It would be fucky.
Fucky wucky.
Sure enough.
Suppose you're doing research into the trade in flowers in your city, and you start by looking at the number of flowers that are sold by a florist in your neighborhood. You find that the random variable x, which you define as the number of flowers you sell on a daily basis, follows a Poisson distribution with parameter blah blah. Compute the variance.
Poisson.
Okay.
Variance is just mu.
Okay.
So easy.
You ready for this? You ready for this? Wah, 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 wah.
Whoa.
Plus 3. Okay, well, since it's still a discrete function, I can actually write this out real quick. So when we have p, x is lecu 2, it's equal to p of 0, p
Lekker.
x is equal to 0 plus p
X is tail
equal to
2
1
lekker.
plus p x is equal to 2. Again, because it's discrete, it only takes values like this.
Yes.
Yes. And we know that Poisson is like this. So let me actually write it out real quick. P of x is equal to k is equal to the fraction of mu to the power k over k factorial times e to the power of negative mu. And now the question, will it actually work with mu? Let's fucking go!
Or just do what I do, have Greek as a keyboard language, so you can switch to it quickly to do symbols.
I prefer
Is that
backslash mu.
yeah, like that's good on a phone.
Yeah.
Or
so then,
when you want to put Greek symbols in like a chat or something where
Mhm.
affix is important.
and let's see. So mu is equal to 3. So then we get 3 to the power k over k factorial times e to the power minus 3. And then we take these 3 for k is equal to 0, 1, 2. So 0 plus 1 plus 2. And actually I can take this e to the power of minus 3 out of the brackets. So I can say this thing times all of this. And you see 0 factorial is 1, so this thing falls away. 3 to the power 0 is 1, so this is 1. 3 to the power 1 is 1, 1 factorial is 1, so this thing is 3. And here we get 3 to the power 2 is 9, but 2 factorial is 2, so this is 9 over 2. So then we get e to the power of minus 3 over this thing. And that's our answer. Use minimally 4 decimal places. And that's our answer. Well, actually. So we're gonna
Hop
have...
in your calculator.
Well, yes, but actually no.
Throw it in
Exactly.
Google. Throw it in Google.
Exactly. I do want to make it a little bit neater, so this is actually equal to 2 over 2. This is equal to 6
17
over 2. This is equal to 9 over 2, 2 over 2, 6 over 2, 9 over 2. Together makes 17 over 2. Yeah.
Yes.
So then we get this thing. And now I'm curious, because I'm going to use this calculator. Is this workable with this? It is already on scientific mode. So I can say E... or actually, I think I can say minus 3 exp. No. Okay, cool. E to the power minus 3. E to the power
Brackets.
minus 3 is equal to this number, and then we multiply that by 17 over 2. Oh my god, I forgot the multiplication.
8.5 times E. I think
E
E.
to the power
Brackets, yeah. Don't forget brackets.
minus 3 is equal to. Okay, so then I would say 0. Blah blah blah, and this rounds to 2. There we go. I'm struggling a little bit with the calculator, but you know, it's not like I'm a university student or something, so it should be fine. Next. It follows a Poisson. Okay, well, cool. This is not hard. So then we get mu is equal to 50 minus 50. K is equal to 58, and this is equal to 58.
Happy inputting in calculator.
Thank you. I will thoroughly enjoy this, Jure said, like a liar. Okay, so we start out with 50 to the power 58 divided by 58 factorial is equal to, yeah, and then we multiplied. Actually, I can say, yeah, okay, now I'll multiply by opening bracket e to the power opening bracket minus 50 closing bracket is equal to. There we go. I was about to say that doesn't look very nice, but blah.
Don't forget to change the comma to a dot. Oh, it actually recognizes the dot.
Yeah, I was about to say I would change that, but like if they didn't do that automatically, then you could fail a test by using a comma instead of a dot, and I doubt they would do that.
Yeah. Isn't that like the way you did in Dutch?
Yeah,
With
after
a
the
comma
comma.
instead of a dot.
Yeah, it is, but you know I never really understood that, so I just kind of use whatever. I use them interchangeably, which is not very good.
Yeah.
Okay, how far are we in lecture
Germany,
2?
but like
Wait, why is there a difference between TU Delft and not TU Delft?
I was about to say because one of them does electrical engineering, but I don't think that's correct.
Yeah,
No.
let's just
Uh,
finish this challenging one, and then I think we're done because.
Yeah, like these are all. Here.
Oh wait, yeah, we haven't done that. Let's do the basic. Let's do all the TOD, and then we're done. Because with TOD, why should we do the non-TOD ones?
Exactly. Also, I like how we did the intermediate one before the basic ones.
Yeah.
That just shows how fucking good we are. Probability mass function, the Poisson blah 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 is. How can something be more symmetrical? Okay, whatever. Then the probability mass function of the Poisson blah 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 distribution.
I think it's more symmetrical because for odd numbers for the no, never mind. That makes no sense. That would be for binomial. Never mind. How can it be more symmetrical?
Okay, so we know the thing looks kind of like this. And when it has a higher number, I think the peak is higher.
Like
And
honestly,
it's slimmer.
I think it might be more symmetrical then.
I think what you want to look at is okay. What you want to look at is look at the variance. The variance is given in a formula on the formula sheet. So just
Yeah, let me tell you, for a Poisson distribution, the variant
is mu.
Yeah.
so if it's higher, it becomes more symmetric then.
Yes.
Yeah, because it spreads out more.
Poisson.
Or-
I see. So apparently, a Poisson distribution approaches the shape of a normal distribution when mu increases.
Yeah, makes sense.
That is pretty cool. I did not know that.
we were not taught this, by the way.
No, not at all. Ah, dude. Oh yeah, I think this is a Bernoulli actually.
I think so as well, man.
Yeah.
This is pure Poisson to my system. Why is the answer outside of the box?
Mm.
Come on. You can do. You're better than this, PTS. You're better than this.
There we go. Ta-da.
Woo.
Mm. The Poisson distribution is a special case of the X distribution. Fill in the gap, use one word as the answer. I have no clue. We know it's discrete, right?
Probably normal, lol.
No, we know it's discrete. So it's one of these four.
The only
If there's
thing
no
that comes
E in
close is
any of them.
binomial. The only thing that comes close is binomial. because of
Everything
the
is
factorial.
everything is a form of the binomial distribution.
Yeah, say binomial.
Never thought this. Ever.
Yeah, we were never told this.
Ha! B.
Pooh!
The expected value
True.
and variant are both equal to mu. Yes, that's correct. Wow, dude, we are so good. Holy hell. Give me a raise, guys. I've got an idea. What if instead of paying the TUDL $14,000 a year, you guys pay me $14,000 a year?
We don't pay
Not-
you
not-
we don't pay them
not.
$4,000 a year. You're just gonna have to convince the European Union that you are.
No. Everybody outside of Europe pays $40,000 a year to me.
Oh yeah, that's a good.
Yeah.
I will, if you can also provide that fancy piece of paper that TU Delft can.
Hmm.
Mm.
I can provide this piece of paper. It just won't, do anything.
Can we really see it as a fancy piece of paper then?
Yes, it is a piece of paper, and it sure as fuck will be fancy. I will use paper imprint and stuff, like the
We have.
reflection and shit.
Why can't we just use like a TI-81 or something? That would be. I could type this in like 5 seconds.
Yeah, honestly.
Okay,
Yeah.
all in all, use the probability mass function to use the distribution function, blah 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 blah. So what they're realistically asking
5.2.
for is
Mu
mu to the power k. So therefore, 5.2 to the power of 4.
Is it less than 2 or 3?
Hmm?
Is it less than 2 or 3?
5.2.
You can have decimal numbers can still be discrete.
Yeah.
Mhm.
And then
Yeah,
over k, which is 4, and it e to the power of minus 5.2.
5.2.
Recompile. Does that make sense? Seems like it does.
What
Calculator
we need to
time.
we need to program a TO Delta proof calculator that uses LaTeX.
That would be sick.
Yeah.
4 factorial times e. Oh. Opening bracket e to the power of minus 5.2.
That's not right.
You think so? Let's try that again. So, oh wait, I think I know where I fucked up. So it is 5.2 to the, oh, not modular, no, fuck. 5.2.
No, you have 5.2 mod 5.
5.2 mod 5.2.
Yeah, no, the mod was
Yes.
unintentional, I know. To the power of 4 divided by 4 factorial times opening bracket e to the power of opening bracket minus 5.2 closing bracket. Why is it doing this? Why is it saying to the power e instead of times e to the power? Sorry that it's taking so long, guys. I'm just figuring stuff out as I go as well. One last try. 5.2 to the power of 4 is equal to this. Yes. Divided by 24, which is 4 factorial. Yes. Times e. I should actually say times opening bracket e to the power of opening bracket minus 5.2. Why is it doing that?
What? Why?
I'm saying what I'm doing, guys. You guys see what I mean, right? Am I being dumb? Holy shit! Okay, I need to actually know how to do this properly because I need to do this during my exam as well.
You did mod again.
Yeah. So we have 5.2 to the power of 4 divided by 4 factorial times opening bracket e to the power opening bracket minus 5.2 closing bracket
Oh yes, it
closing
did.
bracket enter. 0. Okay, it turns out the problem was that I was using the caret key, like the shift 6. It doesn't like that. Okay, a bakery sells 3 sandwiches on average on a daily basis. The number of sandwiches sold follows a Poisson distribution. Compute probability that exactly 2 sandwiches will be sold tomorrow. Give your answer with 3 decimals.
Like in a TI-81, I could just like copy the formula that I used for the previous one and just put the new stuff in.
Yep. I wish.
I get why they don't want to use drafting calculators, but like, come on. I have it right here. Let me use my
3 to the
TI.
power 2 divided by 2 times e. Actually, I should do times opening bracket e to the power of opening bracket minus 3 closing bracket enter. 0, blah blah. Okay, I'm starting to get faster at it. It only took a while.
Ooh.
Are these the intermediate questions or the basic questions? I think intermediate, right? Or like the challenging ones. I think these are the challenging ones. If this is the most challenging we get about Poisson, I will take the W. Okay, let's see.
It really isn't that bad with Poisson, no.
No, indeed. The number of cyclists passed in section during 1 hour is x. Describe the cyclist passed intersection every x seconds. Time that passes. This describes the number of cyclists that pass this intersection every 2.8 seconds.
So you have the top line, the top two lines are the example. So it's 81 in 1 hour.
Yeah,
1
810
hour
in 1
for 80.
hour, which means you need to
Yeah.
divide by 60
Yeah,
to
you
get
have no. You need to do 3,600 divided by 81 to get the seconds between cyclists.
Well, no. So it's Poisson distributed that describes the number of cyclists that pass the intersection every so many seconds.
Yeah. So you have to do.
So we have to calculate the number that
No, it's 810 divided by 3,600.
and then times 2.8.
Yeah.
Yeah. So that is the mu, and then we need to know when that is less than.
No, that's the. Never mind.
Okay, so we have 810 every hour.
Yeah.
So divided by 3600 is every second, times 2.8 is every 2.8 seconds. So this is equal to 0.63. So we have 0.63 cyclists every 2.8 seconds. So we have the Poisson distribution, which is, and I will try to do that by heart now, is the fraction of mu to the power k over k factorial times e to the power of minus mu. Is that correct?
Yeah.
Let's go, boys, we're gaming. So we know mu is equal to this.
No, mu is equal to.
Now this is
One
on
over
average the
2.6.
number of cyclists that pass every 2.8 seconds.
No, 0.63 is the number in the example we have. Oh wait, never mind.
Yeah. So
think I misread that. Why did I give us? This is still the basic. Why? Oh no, never mind. It's not the basic, is it? No, it's not.
no, it's very much not.
Yeah.
So the question is, we want to know the probability that the time that passes between two cyclists is more than 0.28 seconds. That means that we want k to be less than 1. Does that make sense to you guys?
Yeah.
So just because I'm going to say k is equal to 0.99999. Is factorial defined for? I don't know what else to do. So let's see if this works. So we have 0.63. That's not. Oh yeah, that is. To the power of opening bracket 0.99. Oh, 0.99999 closing bracket divided by opening bracket 0.99999 factorial. Seems good.
Yeah.
Closing bracket. Can I say closing bracket as many times? Yeah, okay. Times opening bracket e to the power of opening bracket minus 0.63 closing bracket. Enter. Oh.
Wait, no, you don't have 0 point.
Yeah. I'm trying to go there, but my control left. Oh.
You have to
I think you entered a comma instead of a point.
That doesn't matter.
no.
Oh, it
But it's
doesn't?
actually so this is equal to if we go here. The thing is there a way for me to know the probability of x is bigger than or equal to k?
Just do 1 minus what you got.
Yeah, that's what I think it is as well.
No, as an mu as an k what you get for k equals 1.
Hmm?
Oh, you could just no, never mind. Just do this. This is yeah. This works.
Okay, and this will turn to 66446.
Just see what they want.
Wait, isn't this about Poisson?
Yeah.
But isn't what they're talking about exponential?
Yeah.
Then it shouldn't be about Poisson. What the fuck? What are we doing? Poisson
Poisson.
distribution challenging questions. Okay, whatever. If mu equals 1, so then we have 1 over k factorial e to the power minus 1. So that's basically 1 over e times 1 over k factorial. So therefore, p0 is equal to p1, is bigger than p2, is bigger than p3. Because the only factor that changes is this k factorial.
It's the same question with the cyclist as before. Why?
I have no idea about this entire fucking formula they use. Is this in the slides anywhere?
Don't
Which one?
think so.
This thing with like t is bigger than t if we know that p of x is bigger than or is equal to this thing.
Apparently, it's a combination of Poisson and
Exponential.
exponential.
I don't think I've seen this
It's
anywhere.
exponentially. No, honestly, I don't know. Whatever. Let's hope this isn't on the test. Hey.
Hey! Cheers, brother. I'll drink to that. Fuck your green percent. Suck my dick.
I mean, it's still 3% because you don't have anything orange.
Chat.
Then we start off at green percent.
Okay, the thing is that only took like 2 hours, so we're good.
Yeah.
All good, guys. Okay, let's see. So let's do lecture 3 then. We're almost halfway. We're actually like a third of the way, but
Oh,
living on a prayer and garlic bread. Garlic bread is good.
garlic bread
I
is
wish
just
I
a
had garlic
prayer to the
bread.
gods of garlic.
That is very, very correct.
Amen.
Cheers, brother. I'll drink to that. Continuous random variables. Oh, no. 2 or more. Oh, the okay, the expectation not that hard. Lecture slides. Okay, let's see. Did we already take 2 hours for that one? Jesus Christ.
Yeah.
Open up. Let's see. F is the probability density function, and capital F is the distribution function. So the probability that x that x is between a and b is equal to capital F of b minus capital F of a. Well, this is again because continuous functions we actually take the area underneath, and this is like the antiderivative of the distribution function or of the density function. So then it's just one bound minus the other bound. And this one is not correct because this is always equal to 0 for a continuous function. There is a chance of 0 that you will be exactly at that point. Okay, so we have this graph. What is the distribution function? The distribution function. Well, here, as we can see, it goes up quickly. So then it increases here quickly, then it goes down and stays like constant here, and then it goes up again like this. I don't know why it's not D. I think it was because here it still goes upwards.
Yeah.
Oh yeah, it increases.
It's gonna end flat.
Yeah. Ooh,
Actually, I'm not sure if it's got to end flat, but it's got to at least end at 1.
yeah, it has to end at 1. Full stop. Either way, a continuous random variable is a uniform distribution on the interval if its probability density function is given by 0 if it's not in there, and 1 over b minus a if it isn't there. And that makes sense, right? Because this probability function thing is like... Or this should be like here. So this is a uniform distribution. It has an equal chance to pick any of these values. My top wasn't very flat, but you should very much imagine that the top is flat. So the uniform distribution here, exactly what I was going to show. The uniform distribution here is basically indeed from 1 to 3. It has an equal chance to pick all of those. And again, because this is like a normal line, a constant, the antiderivative of that is a just a straight line with a slope. No quadratic bullshit or anything. Okay, and here again, because you can see the height is equal to 1 over b minus a, or beta minus alpha. That's what you can see here. Okay, suppose a source transmits a message consisting of bits at a constant rate. The probability that the source transmits an incorrect bit at a small interval of length 1 over n seconds is equal to lambda over n. What is the probability that the first incorrect bit is transmitted after more than t seconds? Let's see, yeah. Okay, so this is indeed a let's see, this is the density function of it. However, I don't quite understand how it pulls into this. Because like, here it says 1 over n and here it says t and... Oh, wait, okay. I guess I kind of see. Either way, always know is the formula. Yep, seems good. And after some certain point, it will flatten out. And actually, the point where this will flatten out is equal to 1, obviously. It is asymptotic to 1. I'm not sure if that's the right word, but we're good. Practice now. Earthquakes. Groningen. So this is an exponential distribution. What the hell is this sign? A Pareto distribution with parameter lambda or alpha is bigger than 0 if probability density function is given by alpha over x plus x to the power alpha plus 1. I so don't understand how this fits into anything real life, but I'm going to wait until I see a Graspo exercise, and then it's probably going to give me a solid example.
Sure.
Sure, yes. I put a lot of faith into Graspo. I really shouldn't. I'm going to need some more energy drinks. Jelly, you want some Monster?
Sure. Who needs sleep?
Come over.
No, I'm in a ranked match.
Come over when you want Monster.
Yes, yes.
Okay. Signal with noise. Suppose we send a signal that follows. Oh yeah, this makes sense. So this is just a block wave. Noise is denoted by n. Receive will have signal y equals x plus n. Well, yeah, this makes sense as well. This is just... but this is 2 random variables then. Namely 1 or not. Let's see how they do it. Noise is denoted by n. Suppose we send a random signal. How can we model a random variable? So then they have this graph. Oh, so these are the 2 graphs based on whether whether we're sending a 1 or a 0. Yep. So that's what I said. So that's okay. Ah. Okay, yeah. So these are normal distributions. It's just that they gave a really fucking convoluted, vague example. Cool.
That's the example you always see for some reason.
Yeah, it doesn't make much sense, but
It works. It works.
um,
Why are people in here with like everything like deafened?
they started in here and they want to be able to say to themselves, I attended that thing. So, when they fail, they'll be like, why did I fail? I attended that thing. So we have the standard normal distribution. So again, this is not just any normal distribution, it's a standard one. It's one with the average 0 and the standard deviation. Actually, it's a standard deviation of -1 or 1, but the variance of 1. Yeah, and it's in the book as well. And actually, it's also in the table that we have in here. Quantiles. The P's quantile, or 100 percentile, of the distribution is the smallest number such that Okay, so if we pick some number P, and we want it so that the chance that X, or that for that chance P, we get the number that X is smaller than that. That is very confusing, but I think I get it. So if we have like a halved quantile, then we get like the median. Yeah, okay, that makes sense. Consider the following statements. E is modeled after an exponential distribution. Then the chance increases as lambda increases. Well, let's have a look actually. So they're talking about exponential distribution. That's this one. No, not really, because this minus thing increases a lot faster than this like linear term, so that's false. When we have this thing, then the chance of x is less than mu is equal to a half. Well, that's true. It's symmetric over mu. That's also the chance that x is bigger than mu is also a half. Cool. Which distribution function of a uniform variable, and which is the distribution function of a Pareto distribution. Again, do we actually
No clue
have?
what a Pareto is, but
Yeah, but we don't. Oh wait, fuck, we do. Huh. I still don't have like a concrete example of Pareto, but I hope we'll get one in the on the thing.
well, actually, there is a concrete example of Pareto. Well, look where it got explained. Right
like the
before-
earthquake one. This one.
Okay, then that's Pareto.
Yeah, but huh. I don't know what these symbols mean, man. What is this for? Like 3/4 of an infinity sign?
No, I think it's the same with the equals with a D above it. You know, follows this distribution.
Yeah, but it doesn't follow x is to the power of minus alpha.
Does it not?
No, it follows 1 minus x to the power of minus alpha.
Yes, but 1 is a constant. That's why they don't put an equals there.
Yeah, fair, I guess. We'll see. Where were we? Yeah, this will be an interesting one.
Yeah. One infinitely high point.
Yeah, one singular infinitely high point. Would it actually be infinitely high? Because total probability just has to be 1, right?
Yeah,
Yeah,
but
just
with
means
the
that-
0.
Oh,
this
yeah,
is the
okay.
only. It just means that this is the only possibility that can happen. Everything else is has a probability of 0, and only at 0 is it 1.
Yeah, but it's still the area under the curve needs to be 1, and since the curve is a rectangle, it needs to be infinitesimally, like, not wide and infinitely high.
Yeah, because 1 over infinity times infinity is equal to 1.
Of course.
Very many people pissed off.
1 over t times t with t goes to infinity is 1. That's what it.
That's
That's
true.
what it means.
Yeah. What's the muddiest point? Fuck yeah.
Strider.
Strider. What about 4?
Chisel,
Okay.
eh?
Okay.
Look at 4. Look at 4.
To be fair, I want to do 4 more than I want to do than I want to do 3.
I'm afraid we're gonna do both. Oh, monster.
Come in. Ah. Here you go, buddy. Enjoy your monster pipeline punch. Okay. Continuous random variables and probability density functions. Continuous random variable are described by probability mass functions, and discrete random variable are described by probability density functions. False. It's the other way around. That's just a know-it question. I remember it by like mass is just something tangible. So it's like discrete, and density is like something. No, that's a really bad explanation. In my head, it makes sense. You would like to make a statistical model that approximates the volume of soap used by customers. Is that discrete or continuous? Well, yeah, it's continuous. Within a
Much
certain
soap
range,
or many soap?
it depends. You can have 1 bar of soap.
Yes, but they're not talking about bars of soap. If they were bars of soap, it would be discrete. Much soap, many soap, Jurre.
Well, a bar of soap is, but the amount of soap on a bar of soap isn't.
It
The
depends
amount
if you
of
look at it
bar
at like.
soap on a bar of soap is still continuous. Everything that is
No, the amount of particles in the bar of soap is not. That is discrete.
well,
But
Jurre.
the mass of the soap is continuous.
Would
Well,
it
no,
be though?
because if
Because
the amount of particles is discrete, then yada yada yada. It's continuous. Fuck off.
it's continuous enough. Which of the following data does not correspond to a discrete distribution? Littered or beer sold festivals.
Ooh, many liters.
So basically, it's a number. It's a
Damn.
number. It's a number of cups, but you can't say a number of. Well, you can say, but
Yeah, exactly. No, okay. My fucking entire analogy falls apart. No.
no.
You just need to fucking know it, lol. 1.
Suppose.
You
Yeah,
know,
I
well,
know.
it's how many cars, how many liters. No, but it's like how many cars, how much beer. Like
Yeah,
that's the thing.
exactly.
You have to talk about the-
Suppose we
yeah,
integrate a
the-
probability density
it's
function from
liters
minimum
of
to
beer, but it's
maximum.
how much beer.
Yeah.
The total probability is 1. F is usually used for the density function because the capital F is used for the distribution function.
Green percent.
Okay, I'm gonna be honest, guys. This is just the antiderivative of this, which is 43 over 42 x to the power of 6 minus x to the power of 7 1 over 42. Guys, I'm saying 42. It's funny, right? I'm not a boomer, right?
Looks good.
The question is, do I add a C? I don't think so.
No.
Yeah. Okay. Cool. Why the fuck? Okay. Fill in the blank. F of x, because you have
Yeah,
to.
let me just integrate x.
Yeah. Integrate x. It's always 1 yellow. Or fuck. It's
No.
always 1 over 2x squared.
Shut
Shut up.
You're slipping.
It's 1 over 2
We
a
would
squared
have
minus 1 over 2 b squared, I'll have you know. Because it was integrated from a to b.
Smart
Shut the
boy.
fuck up.
I got a
Probability
6.2 for
density
calculus.
the probability density function is the derivative of the distribution function.
Honestly, I have no idea which one is which.
Okay,
Distribution
so
and
you
density.
have
Distribution is the one which is both.
Oh,
which
it's a mass function for continuous, right?
Yeah. No. Both discrete and continuous have a distribution function, but only continuous has a density function.
I'm gonna get this wrong at a test, thank you.
Because you always do the example with volume. Density has to do with volume. That's why maybe that helps you remember something. I don't know. Maybe it just makes everything more confusing. Helping everyone by not helping anyone.
You're helping me by making me feel slightly more confident, even if it doesn't translate to actual skill.
Wait, no. Yes. So again, we're taking the antiderivative of 3e to the power of minus 3x. Then you divide by minus 3. Get this. Damn it! Why is it incorrect? You divide by the number in front of x, right?
Gonna be real with you, no idea. This looks very correct.
Put a -9 in front, maybe. Maybe we're doing something.
And a plus c, just a flex. Oh, yeah, because you need everything to be equal to fucking 0.
When you fill in infinity, it should be 0. Motherfucker. So our c... Wait. Yeah. So our c is 1.
Yeah.
That's realistically what it boils down to.
Depends on the distribution, though.
Yeah. I already answered this one. Thank you. 43 over 42 x to the
with
power
the
of
exact
6
same numbers as well.
minus x to the power of 7 divided by 42.
At this point, it's probably worth it to just copy all the answers you've already given in another document.
Just
Make
so
a
you know.
cheat sheet.
Yeah.
Okay, the challenging questions, guys. Probability
Damn, this is
density
really
function
challenging.
RV of x is given by blah blah blah. Okay, this makes sense. 3/4. Okay, yeah. So this is actually pretty easy, right? So when we look at this, this means that we have to take the... So we have the 3 parts that we need to consider separately. This part, this thing entirely included. This part, this is not entirely included. And this part we don't really need to consider because it's outside of our scope. So what we're going to do is we're going to integrate this thing completely, and this thing from 1/2 to 3 over 4. So the integral from 0 to fraction 1 over 2 of 4x dx plus the integral from 1/2 or from 1/2 to the fraction of 3 over 4 of 4 minus 4x dx.
Over everything is still making sense. Can't wait to see where it all falls apart.
Fucking based. Okay. Let's see. Actually, this is like so. This is so big. I'm actually gonna start using two dollar signs.
Damn.
What actually is the difference?
This thing is bigger. So here I can say, like, for example, a for all x, we can see x is equal to 3. This will be presented in line. However, if I do that with two things, I'll say for all x, we can see x is equal to 3. This will actually make it like break and put it in the middle of the page.
Mm.
And like this will always this one will also be like more elaborate. So as you can see here, we have like the remember these integral signs, right? How big they are.
Mm.
If I now get rid of one of these signs,
Oh, that's cute.
they are cuter, but they are harder to read.
Also, Jurre,
Yeah.
when doing integral, do double underscore and double above.
Seriously?
No, actually, no, that's for sums. Never mind.
No, it might
Try
work.
it. It's gonna look funny.
I'll see what the difference is.
What?
I-
Okay, apparently it only works in sums. Never mind.
Okay, cool. Anyways,
You're
so
not allowed to.
we need to work with this. Shouldn't be too hard. So what we're going to do is the integral of 4x dx is actually equal to, and I can put a sneaky here, so I can take away this integral sign and change this into this thing. This will be 1 over 2x squared times 4 is equal to 2x squared. And here it will be minus 2x squared. Oh, actually, never mind, I fucked up. This 4 in front will actually become 4x minus 2x squared, which will also go in here. And I will put brackets around this as well. I am very not sure if these brackets work. Actually, I am. It's working here. So this is the answer. I don't think they like it if we fill it in like this, though. So I'm going to simplify a bit further. Let's see. So we start by filling in 0, which gives us 0. And then we fill in a half. Then we get 2 times a half squared, which is 2 times 1 over 4, which is 1 over 2. That's correct, yeah. Cool, and then here we fill in, so first we fill in the 3 fourths, and then we subtract 1/2. So let's see. 4 times 3 over 4 is actually equal to 3. And 3 4 squared is actually equal to 9 over 16. However, this will become, because of this 2 here, it will become 18 over 16. So that will be 18 over 16.
9 over 8.
Yep. 9 over 8. And then we subtract. Let's see, 4x minus 2x squared, where we fill in 1/2. So when we fill in a half, this will become 2, and this will become 1/2. Okay, so this should be correct. And actually, when I turn this into frac 8 over 9, or 9 over 8,
Rick.
frig, I can just fill this in,
Frack.
and it should be correct. Wait, why is this half? Oh, wait, yeah, so this is from the first integral, and this is the first part of the second integral minus second part of the second integral.
Let's go!
Okay, I think somebody else will open the door for me, so that's good. Next.
Yes, I hear footsteps.
We have the following density function.
Briefly. So it's an x. So it's a normal.
Hmm?
No, wait, no, it's not normal distribution.
Alright, so we take this.
I think it's exponential distribution.
Hmm?
It's exponential distribution.
This one?
Yeah.
I don't think it matters. I don't think it's any distribution, but I don't think it matters.
As long as you have like the
Yeah,
the
you need the
density
probability
function.
density function, and then we can calculate the
Wait, no.
probability.
Yeah.
Nope. You need the probability density function, and from that we can calculate the
Distribution
Yeah.
function.
distribution function.
Yeah.
Hey, I'm getting used to the terms. Took me 5 weeks.
Distribution is the one that ends at 1.
Then it's not correct actually. So wait. Oh wait, small f is like commutative. Okay, yeah. So then we are calculating the distribution function. Cool.
Yeah.
It just that it serves a different purpose. You don't just plug in one number. You plug in like a bound.
Yeah.
Okay. So now my question is, what is 10 to the power of opening bracket minus 2.95? Ooh. So this is between 0 and 1. That's kind of annoying. And then I presume that the same thing happens for 10 to the power of opening bracket minus 0.95. Yeah. Alright, nothing to do about that, I guess. Let's get cracking.
Crack-a-lackin'.
Okay, so we have the integral from 10 to the power... actually, let me put it like this. 10 to the power minus 2.95 and 10 to the power minus 0.95. Okay, so here you can see these. And then the function is frac 1 over 2 square root of x. However, we can actually make this a little easier by taking this 1/2 out to the front. So we get frac 1 over 2. And then here all we have is x, or 1 over square root of x. However, that is the same as saying x to the power of minus 1/2 dx. So this is actually what we're left with. So what we do then is, wait,
Oh, yeah, you can actually, this integral is very easy. It's literally just root x.
exactly. So we subtract 1 from this, which becomes minus 3 over 2. We throw that to the front as well. Minus... Actually, then it becomes minus 2 over 3, because we do 1 divided by. And this becomes 3 over 2. And then we fill in the bounds. So again, we take these bounds. We apply that to this thing. And these are the bounds.
Wait, why are you differentiating?
I'm not. Shit, that should be plus 1.
Yeah, it's literally root x. The integral is literally root x.
Yeah, okay,
Because of the
that's my bad. I messed up there.
Yeah.
I forgot about the minus sign, so this is just equal to root x.
Yeah.
However, this will be equal to 2 then? Or minus 2 in this? No, positive 2.
Yeah.
Okay, I can take this positive 2 out of the brackets, cancel it with this 1/2. And this is then just square root of x.
Yeah.
Okay.
Good.
So then we will get square root of 10 to the power of minus 0. So let's see, it's top minus bottom. 9.5 minus square root of 10 to the power of minus 2.95.
Should be right.
Should be right. The only thing I fucked this up
It
is if I 0.3. Huh.
That's actually, oh yeah, it's 0.3015.
Oh, okay, yeah. So they just say do decimal operation. I thought it was exactly 0.3. Like, yo, get the magic number out.
Would that still be correct,
Rounding it to the decimals is that. So
Yeah. Let a random variable that takes this thing with this distribution function. Oh! Okay, guys. I'm gonna concentrate really hard. I'm gonna think. I'm going to focus. And I'm going to answer. Let's see. 1 over 16 minus 1 over 8. No, other way around. 1 over 8 minus 1 over 16.
Is 4 to the power 3 16?
It's squared.
2.
Huh.
You have to integrate.
No, this is
It's
already the
tabular.
integrated version. Yeah, like this is already the integrated version, so you just have to fill in the numbers. These are within the bounds as well. Why is it not working? Oh
these,
my
I think.
god! Oh!
Oh, wait, you oh. We're just stupid. We all just are.
Yeah, that's our green percent loss.
One was saying that like, oh no, it's because we did something completely different wrong.
Not the entire green percent loss, right?
I don't know. It depends if I
No.
fuck up one more. Oh, but here
mean, you can
again, they
always
they
just
do
redo.
say this thing. So now I actually do have to integrate. Again, small f is no integration, big F is integration.
Yeah.
So they use the exact same notation as in calculus, which is pretty pog.
Yeah, exactly.
Pretty book.
So let's see. I will actually first make this the unbound integral, because that makes it easier for my head. We get 8x cubed minus 6x to the power of 5. And that is equal to, let's see. So we get 1 over 4, that means 2x to the power 4 minus x to the power 6. So then, actually I can say, okay. So then the bigger minus the smaller, so this becomes 3 over 4 to the power 4. This becomes 3 over 4 to the power 6. This becomes 2 times 1/2 to the power 4. And this becomes 1/2 to the power 6. I made the same mistake 4 times in my notation there. Check my answer. Green percent still going.
Doesn't even care if you don't put decimal places.
No, I know it doesn't.
So, like, why do you say that? Why do you want us to do extra work that you don't care about?
Exactly. Well, okay. Well, this is just x cubed, right? Yeah. So I can say now it will be 1 over 2 to the power 3. That's 1 over 8 minus 1 over 64. 4 times 4, 16, 64. That's correct. Green percent is still going, baby.
3%.
So
It's the same thing, just different
yeah.
bounds.
So this is just square root. So this is square root of 10 to the power of minus 2.95 minus square root of 10 to the power of minus 1.44.
And the nice thing,
No,
you know
no,
what's
no.
the nice thing about 10 to the power minus 2.95?
What is it?
If you take the log of it, and then do e to the power of that, it remains the same, because, you know, natural log. The natural log is the log n and log e, so you get e to the power minus 2.95.
Log 10 and log e.
Yeah, the natural log works on n and e both.
Mm-hmm.
Fuck
Okay.
anyone who uses ln for power 10. No, you're not allowed to do that.
Exactly.
Americans, fuck off. You're not welcome in this video stream.
I don't discriminate against Americans, only against Republicans. Anyways, let's not get too political, guys. Let's not.
Wrong way round.
Yeah, I was about to say, because that's my first concern. Which one of these two is bigger? And my second concern, which is actually valid, I think. If I look in my calculator.
Yeah, what you can do is you take the absolute value of the entire thing. It doesn't matter which one's bigger. Am I chat or am I chat?
Give in things absolute value of. But the thing is, minus 1.44. Okay, it's still bigger than. Yeah, so I was concerned about it being like bigger than 1. However, I really shouldn't have, because I just realized then it has to be big. Then it has to be bigger than 10 to the power 0. So these are both valid. And now about the order question, I can say.
What?
Oh, and we fucked up the order as well, so your absolute value saved us. And we're still on green %, as per usual. Traders. Holy shit.
I feel like this entire subject is good. It's honestly quite easy.
Why would you feel for this? Just get a grade.
You just have to like get like a 10 for this part and a 1 for the second part. That's the plan.
Okay. A uniform distribution on A to B is noted by UAB.
You fucking lambda.
The uniform is continuous as fuck.
Boy.
The thing is also, even if you just like attempt the second one, you still get a 1. So if you get a 10 in the first one,
Jure.
Yeah?
Isn't this just open bracket 108 minus 36 close bracket divided by 216 minus 36?
Let's have a look.
Damn, I'm good.
So that is the fraction of. Let's see. It's x minus a over b minus a. So that is 108 minus 36 over 216 minus 36. It got me thinking. I think I feel it
0.4.
another way. Okay. The probability density function, not distribution density, can be given by blah. For a uniform distribution, obviously, like this is for an exponential and this is for that one weird guy name. Not Bernoulli. I would think
He's a weird guy, man.
Pareto.
Pareto.
Why are all the probability guys
Pareto.
Italian? What the fuck? Why are we
Pareto.
Bernoulli, Pareto, fucking... What's next? The Mario distribution?
Normale
Racist, but kind of funny.
It is racist.
normale distribution.
A uniform
Mario
distribution?
Giuseppe di fucking...
Yeah.
I don't know
Mario-
if any of you
yeah.
know Giuseppe, but Giuseppe is a good guy.
That's...
Mario distribution goes like grass, desert, beach, ice,
Bum, bum, bum.
forest,
bum,
mountain, cloud, lava.
Yep. Let me actually show you guys the Mario distribution. It's actually
What?
it's a mushroom. Kidding,
No,
it's an
that's
atomic
not-
bomb.
Yeah, no,
that's-
that's the SAR distribution.
That's a
Manhattan
tar
distribution.
That's
So
the that's Einstein distribution.
That's the Manhattan distribution.
Exactly.
That much on it.
I think the Manhattan distribution worked best.
Her.
Yellow
My
wins.
ADC has taken exhaust, what do you mean?
Hmm?
Why would my ADC take exhaust?
Yellow is being very, very attentive towards the learning
Okay.
process.
I learn best when doing something else.
Exactly.
Yeah, I just saw Ahmed boot up Stellaris again.
Like
Hope it crashes
honestly,
again.
this is the best way to take in information, because if I would be like paying full attention and writing every word you write down with like half an hour ago, I would have burned out and would have clicked away. This is the way to learn. I promise you.
Yellow, let me tell you, as the guy who is doing all this shit, I think this works better for me.
I know it works better for you.
Is this correct? No, it's not.
No,
no, it's 0.
It's equals. Chat.
I love how I just type random shit and then I say, is this correct? And the answer is usually no. The distribution function, which is capital F of X. Fucking chat, next subject.
Even if it wasn't, it wouldn't be correct anyways because you put the wrong number down. The right number is the same both times. I fucking love how they use the Ringel S. It's like U209
Beta versus Ringel S.
in German. It's thick.
Fun fact: there's a capital SZ. So see how there's like 2 pages for like look, there's the capital one like since 20.
Oh damn, that explains so much. Jure, can you send it to Melanie?
Sure.
Just that picture. Cheers.
Sharp S. Ooh, that's cursed. Don't give it a British name.
Anyways, you're
What
monitoring
is-
a process whose output is known to be continuous random variable with a uniform distribution where you know that B is some number bigger than this. Let X be the output of the process, the probability that the output is not between this is equal to 0.7. Scritch, scritch, scritch.
I would say fucking fill in. So, you know that. God. Just do the calculation.
Just do the calculation, Pepega.
Yes, because you know it's higher. So 501 or 672 minus 501 divided by. And now I've got to think.
So let's see, the probability that the output is not between these.
Yeah, then the output the probability that it is 0.3, and that's how you calculate this.
So let's see, X is uniformly distributed by this. We know that this is true. Oh, I see. So
When in doubt,
I didn't
sketch
see
it
these
out.
two numbers are the same thing. That changes the question quite a bit. It makes it kind of doable and stuff.
Yeah.
The
Always
prob-
nice when a question is doable.
The probability that it's not between these is 0.7. Okay, so I'm gonna write this down. Write it down. Write it down. So we have the probability of 501 not less than or equal to X not less than or equal to 576 2 is equal to 0.7. It actually exists. Holy shit! I didn't think like not equal, not less than or equal to it would exist, but it does. So therefore, we can say that the probability that this is less than or equal to is equal to 0.3. Okay. So therefore, the integral between of oh wait, I don't actually have to do an integral because it's already calculated for me. So we want to know f with these two values is equal to d. Okay, so what we actually want to calculate in the end is equal to, so the fraction of x minus 209 over beta minus 209 is equal to 0.7 or 0.3. Actually, that doesn't make much sense. It's something like this. However,
It is.
let me draw it out real quick because I'm confusing myself. We
When
know
in
that
doubt,
it's
draw it out.
we know that it's like this. However, we know that this part of the probability is equal to 0.3. This here is beta,
What's the length of the interval?
Uh,
501 to 672.
Also,
Calculate
it goes
the
to at
length of
least
that interval.
672. It,
No.
yeah.
Yeah. But calculate that interval, the length of that interval.
this thing?
Yeah.
You mean 171?
171. So 171 length is
Times
0.3.
Yeah.
So
171 times fucking the distance between 209 and beta equals 0.3, or divided
Yeah.
by the different.
equals 0.3x.
Okay, so
Our x is like I divide by x at the start, you multiply by x at the end.
yeah. So then we get 173 divided by 0.3 is equal to x.
And that actually it's times 0.3.
No, it's not.
No, because we're trying to get the divided by 0.3.
So it's 570.
That's the length of our interval.
Yeah, and then we
570.
have to
And
add.
the length of the interval is not beta itself.
Yeah, no, we have to add 209.
Yeah.
Mm-hmm.
779.
Easy peasy.
Quick math.
And this is something where it really helped. That's half of the thing. Cool.
This would have ruined our green percent run.
Well,
We're
not if you
fucking
had
good.
me.
Wait.
Nice.
Well, this is a lot easier then.
Yeah, okay, so we the distribution function is 1 over.
So it's wait.
672 minus 501.
Minus 5.
672 minus 501. Over 747 and minus 209.
Wait.
Yeah, straight up. Look.
Why are they using A and B here as well? Oh wait, no, for X. Okay, yeah. Oh, I see. Okay, yeah. So what we're doing is we are doing 501 or 672 minus 209 over 747 minus 209 minus 501 minus 209 over 747 minus 209.
You don't even need that. No.
You probably
You-
don't. However,
No,
I choose to. Because this one makes a lot more sense in my head. I know you can simplify it because
Yeah.
these had a common factor and
but
stuff,
look
but
at
I
that,
don't
look
care about that right now. I just wanted to make
the
sense in
one
my
at
head.
the bottom there. The length of the interval at the top over the length of the total interval. Because it's simply just a part of the interval. So you don't need that one there. You just need the very simple length of interval on the top minus length over the length of interval on the bottom.
Or
Yeah,
just
okay, that makes sense.
do it in whatever order and do absolute value.
Deel gedeeld door geheel. Like it's literally calculating a fraction. Because the entire thing is 1.
Green percent, woo!
So far, we do have green percent.
Those were the challenging questions. What?
Yeah, it's a uniform distribution. There's not much challenging in there.
Yeah, it's a brick.
Yeah.
I like that.
The exponential is continuous. Probability density function of f of an exponential distribution with parameter p is given by.
A lambda thing. Yeah.
Can I copy that? No, damn it. So it's lambda e to the power of minus lambda x.
E.
Yeah, okay, cool. Exponential is denoted by exponential of lambda. Yeah, the uniform distribution. This probability density function. We're doing questions about the exponential distribution. I really hope.
Yeah.
Okay, next subject. Practice question.
Practice question. So we have
Yeah, so again we are working with this thing. So it is 1 minus e to the power of minus lambda x. 1 minus e to the power of minus 43 times 0.057. I
No,
really-
lambda is 0.057 and oh wait, never mind.
I was about to say, it's a multiplication.
The order doesn't matter.
Yeah, like I know the order is different,
Yeah.
but it's a multiplication. So I just did whichever one was easiest to write first. Its probability density function is given by lambda e to the power minus lambda x.
No, for yeah. Never mind.
And f is 1 minus e to the power of minus lambda x. Did I fuck it up?
You always fuck it up.
Minus.
1 minus e to the power of minus lambda x. That's what I did.
A. It's FA, not FX.
I'm gonna punch something. I'm going to punch something.
You have to redo the thing now. Oh wait, no. There's one more question. What? Why does it say 3 if we already done 3 questions?
If I get 3 out of 4, will that be correct? Will that be like good enough?
Yeah.
No, it's 80%.
Can I stop it now?
You
No,
can
it
exit
remembers
and
how far
restart.
you've been.
Fuck.
No, you
Okay.
can exit and restart. You can just like.
Oh, you can
practice now
restart.
instead of
That's
continuing
true.
practice.
That I don't give a shit, Jura. Honestly, you're gonna fuck up somewhere.
Yeah. Okay.
If it's not here, it's at the covariance.
I will fuck up at covariance. I'll take the L.
Why is this? Okay.
Oh. Our green percent lasted almost 4 hours.
Jura,
Yeah,
you
you
can
can-
just do. If you want, you can just do it again.
Yeah.
Wait,
Yeah,
actually, you're right. 1
Yeah.
minus a to the power of minus lambda. Oh fuck, forgot a slash. Slash lambda a.
Hey.
A lambda. Fx is lambda e to the power of minus lambda x. Oh, that makes a lot of sense actually, because that minus lambda
single
cancels out.
A.
They become minus e to the power of minus
Yeah.
lambda x. And then you just add 1. Cool. And then we get 1 minus e to the power of minus 35.4 times 0.054. Wow. Anyways.
That was fast.
Wait, that was the intermediate?
Yeah.
Okay. So then we get 1 minus e to the power of minus 0.051 times 61.6 minus opening bracket 1 minus you can get rid of the 1 because it's a constant in a blah 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 0.051 times 54.7.
Why are these long processing times always so nerve-wracking? Like
I just play RuneScape on the side, then it's not nerve-wracking.
Check the answer, please. Why is it? Seriously, why is this taking so long?
It's taking a lot.
What's happening?
There we go.
Yeah.
Compute P is actually this is relatively easy because that's 1 minus 1 minus e to the power of minus 4.5 times 0.4. Shit! No, I fucked up.
Bracket.
I should have added brackets. No,
Oh.
I'm a nerd. I'm a nerd. Okay.
I mean, we all
Yeah.
are.
Get nerded on.
Oh no. This exponential function has drip. Geometric and exponential disputes satisfy the memoryless property.
How did we spend 3 hours on lecture 2?
Yes.
Yeah. No, 2 hours.
2 hours.
These are the total times, not the segmented time.
Yeah.
Ah.
It's only 2 hours. We're good.
Yeah.
Okay. Let's see. So, the chance of x being bigger than y and z, given that x is bigger than y, equals to Huh, this is interesting.
Hmm.
It's not this one, I don't think. Or would it be? The chance. So we know that x is bigger than y. And the question is the chance that bigger than y? No.
To write them out.
Hmm.
Actually, I have no idea what the like. We didn't get explained this,
No.
but I would say take like
Let's
the
go.
take the geometric and like write them out. That's what I would do. Just test them.
1 minus e to the power of minus 0.21. Calculations in my head. Boom. Okay. Let's see. 1 minus e to the power of minus 0.042 times 53 minus 1 minus e to the power of 0.042 times 17.7. Practice more. It's this one. Haha! 1 minus e to the power of minus 1.05 times 2.4. Next one. You can really tell that there's like only 3 different choices here.
It's not that hard. Like
Yeah,
so
exactly.
far.
1 minus e to the power of minus 0.033 times 33 times 70 minus 1 minus e to the power of minus 0.033 times 33.3. I am good. Next subject. Oh, the weird Italian guy that's not Bernoulli. Is he Italian? Pareto.
Euler.
Pareto. Where
Yes,
was?
the very famous Italian Euler.
Okay, let's see.
I mean, the exponential distribution should have been called the Euler distribution. Change my
I
mind.
love how depending on what time you're talking about, Euler could be German, Polish, or Russian.
He was Italian.
Euler is mathematical. That's all you need to know.
He was actually Italian, guys. Holy shit. It's a symmetrical distribution.
Well-
Let me have a look at the formula. I don't think so.
When the mathematician is Italian.
Lambda over lambda plus 1. I don't think so because this plus 1.
It's essentially just the offset.
Oh, true, because this would be equal to x times x to the power. Yeah, okay, then it is symmetrical. No! No, I don't think it is actually.
What? What's the question?
It is symmetrical.
Which one?
Pareto.
Pareto.
Pareto. This one.
No.
Because it's x
Alpha.
times x.
Alpha can be ignored. 1 divided by x. Why would 1 divided by x be? Yeah, it's the fact that it's 1 divided by x. Yeah, why would... No, that's... 1 divided by x is like a slope. A slope...
Yeah,
Like one of
plus
those
if
cheese
we look
slopes,
at
that's not...
if we look at Pareto, this is a Pareto distribution.
Yeah, that's...
Generic Pareto distribution is I mean, if it's a generic one, then maybe this is this. That's this one. Either way, I'm saying this one. Yep. Cool.
Para.
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 Para pa pa pa.
The new JoJo be like para 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 para.
Ora 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 ora.
Do we know?
Anyway, the Pareto distribution is used to describe. Fun fact: all of the CSE is either queer or watch a JoJo or a furry. One of them.
All of them.
Actually, watching JoJo is a subset of being queer. Never mind.
Yeah.
Pareto distribution is used to describe events or situations where the outcomes is not evenly distributed.
Being a furry is also kind of a subset of being queer. So like.
Yeah, okay.
Yeah.
Well, you're queer.
Excuse me, what are you telling us, Konrad?
Yes, you are a furry, Amund. Deal with
No,
it.
I'm fucking not.
Also, everything you say,
makes it more obvious.
would like to remind all users that this is all on recording.
Conrad, the man who must draw orcs.
Okay, hold on.
And
Oh.
I think we should get Pigeon in the
it's
in the call.
much more work
Yep.
than playing a guy who dates an orc. Like, come on.
I know, I'm just messing with you.
Also,
Like you wouldn't. It's not like
Conrad.
you wouldn't date an orc.
is Conrad spelled like Comrade or like? No, it's with an N, right?
Yes. Why?
Because every time I hear your name, I think they're talking about Comrade.
Yes,
God.
Conrad.
Ja!
For the motherland.
Ja!
I mean, the first half of my
name.
It is corresponding!
I mean,
I am so
if you
sorry
have
for
the-
everybody else in this call. Let's continue.
I
The
think you have my
distribution
name in
function
my-
is this distribution function is derived.
Bernoulli.
The gamma distribution.
Bernoulli. Why are there so many times? Like you should.
Okay, guys, I am going to take a quick gamer piss.
Yeah.
I recommend everybody else who needs to take a gamer piss to also take a
It's
gamer
not
piss.
just
See you
any
guys in a
piss.
bit.
It's a gamer piss.
Of course, we're gamers. We're gaming.
Yeah, you know
We're
what?
gaming.
But everybody
Yeah.
knows what makes it a gamer piss is the burn.
No, it's
The mountain dew.
Shut up.
red light in the toilet.
It ain't a gamer piss if it doesn't burn.
Jesus.
So you need to have a gamer toilet with RGB lighting along the rim.
You need to have a gamer urinary tract infection.
If you're pissing and your piss is RGB, I think you need to see a doctor.
Hey, no, your piss has gotta glow. It's
If
gotta
your piss
glow
don't glow,
or
you
it's
gotta
gotta
go.
go. Hey,
Great minds think alike.
This video is such a mess.
I feel bad for Euro when he comes back.
Nah, this is how every video ends up.
No, but the thing is, he
Like-
will never watch this. You will never
he
know
will.
what's in here. No. You think he seriously watches through it?
No, he
I
doesn't.
mean, you might be like, "Ooh, people are talking about piss in this video."
He's gonna get
it will be unlisted, but he's
demonetized.
still gonna upload it. I mean, he's not monetizing it. It's gonna be unlisted because it costs
True.
material. But like,
No. It's gotta glow or it's gotta go. That's what my mom always told me.
Sounds like a Forrest Gump reference. My mom always told me.
Mom always told me life's like a box of chocolates.
Exactly.
You never know what you're gonna get. My mother told me someday I will be.
Mama told me you should know our world is cruel and blind, but to make your way through cold and heat, love is all that you need. I believed her every word, more than anything I'd heard, but I was too scared to lose my fun.
I love how when I
Only
come
going
back
to cry
and this
alone.
is all in recording and I just hear somebody singing.
Oh
It's not the worst part, don't worry. Don't
We're
worry.
talking our RGB gamer piss.
Yeah. 1080p gamer piss.
Hey.
1080p game. What if I want my gamer piss in 4K?
60 FPS gamer piss.
If your piss don't glow, it's gotta go.
Okay, guys, let's continue.
Call that a glow up.
Practice questions for the Parallel distribution.
Pareto.
Pareto. Patero.
Apograph.
Oh.
Pineapple.
Which of these following graphs corresponds to a par-1 distribution? Well, you see, the graph is
Pareto.
actually this thing.
That's the
So
wrong-
it starts, like, when this thing is 0, it starts at 0.
It's exponential.
So it's the lower
You're-
one.
you-
Wait,
no, you
Motherfucker.
exponential.
but even then, like, let's see.
No, Pareto is the one that doesn't start at 0. Pareto never
Well,
starts at 0. except it has
what
some-
kind of thing is it's a distribution function.
Yeah, and it never
So then
starts
it
at
is
0.
then it is actually indeed the
Distribution function ends at 0, doesn't it? Or at 1?
it's 1
Yes,
minus
for
something.
X, for X. X starts at 1 for Pareto, always. Unless it's like a
I
complicated
thought the
formula where it
value
doesn't keep one.
of the distribution function.
Whew. Oh, it's about the power 1 distribution anyway, so I was like, what is the variable? But it's actually given. So this thing describes the this thing, which is the
Ba-da-ba-ba-ba-ba.
density function.
Ba-da-ba-da-ba.
Ba-ba-ba-ba-ba.
I'm loving it.
I love how that's just become like the jingle of
Yeah.
capitalism. The larger the parameter alpha
I
of the
really-
Pareto distribution, the more skewed it becomes.
Well, yesterday I saw like one that was like from Gordius Petronas, is like that one Tumblr account with the purple, pink icon, that guy who always does the funny stuff. And it was like, if I wrote a book where the evil mega corporation had a smile as their logo, I would get fired. But here we are.
Yep.
Like, come on.
Suppose you have a continuous random variable x, which is known to follow a para distribution, where this thing holds. What is the value of a? Well, this is really easy. So, I love how every time I just say this is really easy, and then proceed to give a very difficult explanation. So we know that.
So this is very easy. You just have to blow up the universe.
Yeah. So first we take p equals np. Well, we divide by p, and then we just get n is 1, or p is 0. So we have px is bigger. Geku 25 is equal to 0.63. Therefore, 1 minus. Oh, actually, let's say thing being lower than 25 is equal to 1 minus is equal to 0.37. Okay. And because this is a less than, this actually is the probability or the distribution function of a Pareto distribution, which is actually f of 25, or let's say p of x is less than 25, is equal to p of x is less than or equal to 25 is equal to f of 25 is equal to 1 minus x to the power of minus alpha. I was an alpha! Okay. So we know this thing, and this thing is actually equal to... Well, we know x, that's 25, and we want to know alpha, and we also know that this thing is equal to 0.37. So when I copy this part over to the next line... Oh. Recompile. So this is actually what we're left with. What I'm going to do now is I'm going to add subtract 1 from both sides. So this is going to become minus 1 plus this thing, which is actually equal to minus 0.63. Then...
You can take the minus out from both sides.
Yeah, I can take the minus out from both sides, you're right. Then I'm going to take the log base 25 of both sides. And I'm gonna take the minus sign here. Therefore, a equals to the minus 25 log of this thing. However, I'm not sure if we can enter logs with a different base.
Just do log divided by log 25. Also,
Yeah, that's
minus
true.
log, or just do log 0.63 divided by log 1 over 25.
This works as well.
Works as well.
I love how little questions there are for these things. Like, actually.
Yeah.
And this one is
It's still a
still...
lot of questions, though.
This one is also really easy. So this is just 1 minus... or actually 1 minus 6 to the power of... is that correct? No, it's actually 1.5.
1.5.
Or actually 6 to the power of 6 minus 1 minus
1.5 to the power of 6?
Yeah, 1.5. It's x to the power of.
Yeah.
I think.
So the thing is, to the power of is equal, like the thing you do to the power of, and it's actually minus 6, my bad. The thing you do to the power of is actually equal to the variable, and like the base is equal to x.
Base and the speaker.
Wake the people,
Base.
go to war.
Whoa, GME up 6.
Whoa, let's go, let's go.
Go.
Not financial advice, I just like the stock.
Volume kerk droog, hey.
Kirk droog. Normal distribution, finally, something I am familiar with. This is the probability density function. Yes. Fuck.
What?
Wait, this is the probability. Why did it say capital F? Fuck off. The value
Technically, they can
parameter
name it
is,
whatever the fuck they want.
equals the mean. The value. Oh, the standard. Corresponds to the probability density.
This probability density function corresponds to the what distribution? Come on. Come on. Come on. Come on.
Shut the fuck up. I wanna cry.
Look at the calculation for the normal distribution. It is such a horrible mess.
Yeah, not only that, but like we are not
That's
given.
what you just give us the values.
Like,
they can just
Here,
give us
if we look at the normal distribution, right, we do not get the distribution function because it is not exactly calculatable. It's only approximatable.
Square root of 2 pi. Why would you take
Yeah.
the square root of
That's
pi?
why they teach us how to convert to the standard normal distribution and then give us the table.
Normal distributions are weird, but they're nice. They work
They-
very
they-
well.
They look pretty-
They're
they look
everywhere. It's like when your first grade Spanish teacher says first grade Spanish is everywhere, but they're actually right.
Yeah, like the
Yeah.
Spanish teacher is not right, but this one is.
Yeah.
It's symmetrical as fuck.
Yeah, it's like
don't
when
get
your
more
math teacher
symmetric than
says-
this.
It says you're gonna need math for everything. But they're right.
Actually, can I derive that it is symmetrical from the formula? Yeah, because it's getting
Yeah,
squared.
squared, yeah. So it's equal on both sides.
Or well, it's equal to both sides relative to mu because mu is also here. So if you
Yeah.
have mu plus something, then this becomes, mu plus something minus mu is equal to something. And if you have minus something plus mu, then that's going to become minus something, plus mu minus mu. That's going to fall away. So it is symmetric across mu, which makes sense. One.
1. Haha! 1!
Actually, fun fact, this is not only 1. It could theoretically also be minus 1, but we've just decided that it's 1.
Yeah, we have
Because this
no,
is- this
the
1 is equal to n squared.
The variance, the variance is always squared. The standard deviation can be negative, but the variance is always squared, and it
Exactly.
gives you, it's mu sigma squared. So 1 is the standard deviation might be minus 1, but the variance is always positive.
Okay, kind of fucked that one up.
It's still gonna be green.
Next.
3% is actually not that hard with so many short ones.
Yeah, indeed.
Imagine 3% for linear algebra is a nightmare. Like I prefer this, a lot of shorter tasks over like one very large task.
Yeah, I totally agree. It is way less daunting now that I know
Yeah.
that they are all like 4 or 5
Yeah.
things long.
Mu sigma squared, by the way.
Yeah, correct. Okay, next. Probability density function of the standard normal distribution is given by.
It's
Actually,
over,
I know that one. It is.
it's the top right.
What is the difference in these two?
The fraction in the power.
Oh yeah, okay. Well, we know that it's this one.
Yeah.
I can't read it well enough. Give me a sec.
Function? What?
So it is. Let's see. It's not this one. Not this one.
Standard
It's not
normal distribution. Oh.
this one. Fuck standard. Oh no, that's so annoying.
So
So this one is 1. That one is. Yeah, it's this one.
yeah.
Yeah, it's that one. So annoying, bruh.
What happened?
So annoying.
We clicked on the right one for normal distribution, not for standard normal distribution.
Yeah, it specifically asked the standard normal distribution. I'm
Yeah.
so upset.
Yeah, okay.
Okay, well this is relatively easy. So this formula sheet actually gives, like, says what it is. So these are the right tail probabilities.
Yeah.
So P of Z bigger than A. So then I can go to, and it asks 0.88. So 0.88 is this divided by 5,000. No, wait, 0. This. Yeah.
Yeah.
What is the fuck? And this is mu sigma squared. Let's go!
Ooh, still green.
Still green, guys. Still green. Challenging questions. So let's see. If it's less than negative... Well, I mean... This is... Oh, wait. Percentage? Percentage of data that can be found in the left tail of the...
Yeah.
So it just find the number and then
Yeah.
use the... turn.
Just times 100. That's it.
Yeah.
So it's 1 minus everything that is
No. It's good, like...
yeah, 1 minus
no,
everything that
this
is
thing is
lower than
symmetrical, right?
1.25.
So...
Asymmetrical, so.
Yes, but that's why it's 1 because you only
So
know
P
have the
of
left tail, so
Z
it's 1 minus everything that's lower than 1.25.
Minus 125 is equal to P of Z greater than equal to 1.25.
Yes, but that isn't in your table.
Yeah, so we want to know...
Oh wait, is it? Damn. Never
Yeah,
mind,
so
sorry. I thought it was left tail.
It's 1.25, so this one. So the number would be 0. This. However, because we have to find a percentage, it's like this, and round to 1 decimal point makes it this. The only reason that question was hard because of the like decimal pointing. Calculate the probability of... Wait, that's fucking easy. 1.50. Green percent, let's fucking go! Wait, that's 3 done. 420, guys! Holy shit, that's so funny.
Blaze it.
Blaze it. Realistically, though, we did.
We should have waited the 42069.
We should have waited to 42069. Shut the fuck up.
Hmm.
Okay. Cool. I love the fact that like lecture 2 took 2 hours, and this one took less than 1.5 hours.
Oh damn! Sweet timing.
Dude, that's time safe. Fuck. Bandream. Fuck CFY. Fuck Notch, and stay hydrated.
I hear Dream.
Oh yeah.
Hell yeah.
Nosh didn't even make Minecraft. What a dummy.
What a dummy. Don't you know that actually the Minecraft B is the one who made Minecraft?
Exactly. First Jeb go to the Minecraft B, and then the Minecraft B made Minecraft.
Exactly. It's like self-writing code. Except for this one is
Yes.
actually good.
Well, no, I wouldn't call Minecraft good, but
Yeah, okay. To be fair, I have digged around in that code more hours than I'm willing to admit, and it is a mess. I have more respect for Kalle. He simulated terrain.
You've
I
got
really
the door.
wonder how much better the actual code base is if you like have the actual code, or if it's any better at all.
Did you not look at the actual code while making it?
Well, no, we only have decompiled versions of the code.
Yeah, but we use mappings provided by Mojang.
Those are very incomplete mappings.
Yeah, I don't use the ones used by Mojang. I don't think.
No, I don't either because they're incomplete.
Yeah, they're
Nah.
like, they're like, yes, we have the block total, and we call the function on that because that mapping just isn't there.
Yeah, we don't get function names. We only get class name mappings.
Yeah. Either way, the yarn mappings are better.
Yes.
Let's get started with lecture 4. Like we can fit lecture 4 in here, right? I think we can do 4 and 5, and then tomorrow we can do 6 and 7.
Yeah, but we could actually stop on the time we planned to, theoretically, because like 5, 6, 7 isn't as much as first few. I think.
Yeah, true. Like, let's
The
see.
few
We
of
have.
a difficult concept, but it isn't like a lot.
So let's do lecture 4, and then like we can do 5, 6, 7 tomorrow.
Sure.
Also, so we have 8. Yeah, okay. There's no 9. So we have 8. 1, 2, 3.
Do we even need to do 8?
No, but this is just for like I want to see for
Oh, okay.
for next time. So we have 1, 2, 3, 4, 5, 6, 7.
What?
17 and 18 either practice or they forgot to put it on. Same with
I'm
12.
gonna be
12
honest,
as well.
guys. I'm gonna be honest. I am actually more hyped for this subject than for linear algebra because that shit took 11 hours, and this is only gonna take like
Yeah.
11
I
total.
It would have taken way more.
Yeah, like I thought it was gonna be way worse. I really don't think this is too bad. I don't understand how this is like a. Okay, probably the test will be terrible, but so far it seems relatively doable.
I'm honestly just going for get a good grade for this thing and absolutely screw up the statistics part.
I mean, I'm gonna do the statistics like Graspel as well, obviously, because I am the one carrying this entire course on my back with my stupid remarks while you guys do all the work.
Yeah.
Apparently so.
Yeah. Shout out to that
Well,
one guy who
marking,
said he
so-
passed the entire course by just watching my things. I'm like, what? How? You good?
Well, you do technically go over all the material.
That is correct.
I would even argue in a shorter amount of time than they do.
Yeah, no, like very much shorter. However, it most certainly helps if you've seen all the concept before.
Definitely.
Okay, let's see the lecture. The expectation of x is most likely is the most likely value of x. No, it doesn't even have to be a value of x. Wait, does it?
I don't think so.
No.
It
Yo,
also
what's the
says
expectation?
none, so
It's the expectation of a die, you fuck.
Yeah. An expectation always positive, not true. So let's see. Probability math function. So we have these three things. The expectation of x is equal to minus this plus this. So that is, yeah, that's 1/5. And then x squared is going to be minus. Oh, actually, it's 1 times this thing and 1 times this thing. So that's 3/5. Didn't we already do a question regarding this with the change of variables when we did the probability math thing?
I think
Oh,
so.
Yeah, when it said
think
like a
so.
half x to the power 4, where I fucked up the calculations. Yeah, we did.
Okay. Change the variable, that's where I think it's gonna go wrong for me.
I mean, that's not too bad. Let's see, the expectation is the sum of for all i's that exist, it's just ai with a chance of p.
Times a chance, yeah.
Yeah, times the chance. So, like for example, for a dice, it will be 1/6 times 1 plus 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3 dot 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 1/6 times 6. This actually evaluates to 3.5. So the average value for one die you throw is 3.5, which is also why when you throw 2 die, the expected value is 7. And you can see that a lot better than, the normally distributed 1 die. Let's see, the expectation of continuous random variable is x fx dx, which, yeah, makes sense as well for like all values of x. So this is basically just a continuous interpretation of this one. Okay, that makes sense to me. These are the expectations. Woo! They're on the formula sheet.
Yeah.
Questions? Okay. So this is a change of variable formula. When you have the expectation of some function of g on your random variable, then you have to, instead of summing all the elements times the chance, you have to sum all the elements with that function applied to it times the chance. And same thing when it goes to when it's continuous. And this is an important one. I will come back to this one. I know that for sure. Actually, there we go. The variance and the standard deviation. So the variance is the expectation of x minus the expectation of x squared.
Yeah, you're never gonna do that.
No, but it's good to know. And the standard deviation is some of some random variable x can be defined as blah blah blah. I remember this honestly by the fact that the variance of a normal distribution is sigma squared. Therefore, the standard deviation of a normally distributed function is sigma. So yeah, I remember standard deviation is sigma, and the rest will come by itself. And these are the expectation and variance of a bunch of stuff. Cool. I love how there's just a random 1/12 here. Motherfucker, just. Yeah, well, I mean, correct. And the change of units one, well,
It does make sense from the way it like ex squared plus ex squared. Like
yeah,
that
yeah,
thing.
definitely.
It makes sense from that thing.
Yeah.
In some way, I'm too lazy to calculate that right now.
I did not know that the expectation of a binomial. Oh wait, actually, that makes a lot of sense. Actually, cool. Yeah, these are all like you can try to comprehend them, but you can also just look them up. So I don't really care. Okay, so this thing you can just put it in. Like I don't know. This one makes a lot of sense in my head. This one makes a little less sense in my head, but you know.
Who
Actually,
needs it to make sense as long as we remember the formulas?
exactly. And here,
Which one makes a little less sense in your head?
This one. But
Let me see if I can.
No, I understand. I understand it. Like it has been shown in class before.
Like the fact that the plus s is negligible is understandable. The fact that rx is r squared's variance of x, that's a bit less, but you know.
No, actually, this follows from the change of variables formula. Like from this one, where is it? From this one, and he actually showed that in class, so I understand why it is. It's just a little bit iffy. Let's see, change of units formula. And again, I need to really remember that the change of variable formula is the one where doing e of something of like some function here can actually be done in here as well. And the change of units formula is this. So yeah, that's like the difference between those two, and I really need to remember that. Okay. So there are following two statements. It's always the case that this is true. Well, you see, the variance is equal to ex squared minus ex squared. And we know the variance is always positive, because, you know, negative variance doesn't make sense. So ex squared minus
if you think
ex
is imaginary.
Yeah, exactly.
Your standard
Minus
deviation.
ex squared is always going to be a positive number, therefore this one is always bigger than that one. So, you know, that's why we know that one. And here this is just practicing, so we have this thing falls away, this thing becomes squared, that's for variance of x. Okay. We've considered the three graphs on the right, let m be the median of a distribution. Let's see, the chance of x is bigger than m is equal to a half. This makes sense, that's like the definition of a median. That means there's like just as many values above it as below it. So let's see, the expected value of this thing will be somewhere here. However, the median will be somewhere here. You guys see my pointer, right? My cursor?
Yeah.
So again, the expectation will be somewhere here, but the median will be somewhere here.
Yeah.
That's not true. Wait.
No, the median is the middle value. So it's gonna be more central than the
Oh,
expected
it's false,
value
so it's the other way around.
skewed,
Excuse
in
me.
the skewed data set.
Yeah, no, it's false, so that's
Yeah.
my bad.
Yeah.
And for this one it makes the most sense, obviously, because the median is equal
Yeah.
to the expectation. Yeah, so there it's just exactly equal. Here, the median is here, but the
Yeah.
expectation is here. And here, yeah, the expectation here and the median is here, so yeah. Again, getting my head wrapped around the concept of median versus expectation is going to be a bit tough, but I'm sure I'll manage. That's the muddiest point. Cool.
What was the difference?
Median is the middle value
Oh, yeah,
expectation.
median. Yeah, well, mean. Yeah.
No,
Mean
that's
versus
it.
mean.
The thing is median versus mean.
Yeah.
That's the entire difference.
Yeah, of course.
Okay. Basics. The expectation of a normal distribution can also be given by this thing. That's me. We just know that. Suppose exponential distribution with parameter lambda. Following the expectation of RV following an exponential distribution is given by expectation of an exponential distribution 1 over lambda. Okay, consider the following definitions. Variance of x is the expectation of x minus expectation of x squared, and variance x is expectation of x squared minus expectation of x squared. Okay, which definition can be used to compute the variance of a random variable x? This one seems really hard, but it might be possible.
Mm.
I know this one is probably possible.
This one's the right. That's the actual formula for variance.
Well, both of them are. Like, both of them are
Yeah.
actual formulas.
Mm.
Damn
Oh,
it.
so both.
It is both, yeah. Let's see. Compute. Okay, then it would be r squared. No, actually, it's r times e to the e of x plus s.
Plus s.
Capital X. Capital X.
Thank you. Okay,
What,
compute the variance of x.
Why
Well,
was
variance-
that thing there?
Hmm?
Like the why was what you did wrong? River?
Capital X. So I did a lowercase x.
Capital X. Okay. I thought you put like in like a wacky lambda or something. I was like, what?
Oh yeah, it's not x. It's actually the gamma function. Yeah. So anyways, the gamma lambda lombard. Okay, so the variance of x
squared
is
minus
e
e
of
of x squared or something.
x squared minus ex squared. So it's 1/4 minus 1 over 36.
Yeah.
And again, we can see that this would be
No, isn't it EX squared minus EX squared?
Let's have a look. Oh, the wrong one. It's ex squared minus ex squared.
Yeah.
Ex
Oh, yeah.
squared minus ex squared.
Wrong way around. It's very confusing because EX squared or EX squared. Like.
Yeah, it's ex
Yeah,
squared.
it's a really fucking.
Yeah.
X squared minus EX squared.
Yeah, exactly.
Yeah.
So basically,
What I remember
it's
is at
ex
the
squared
end
minus
of,
ex quantity squared.
Exactly. At the end of the formula, the Klein always says quantity squared, which means square the entire thing.
Yeah.
So that's what I remember. I just remember him in my head: ex squared minus ex quantity squared.
The expectation of a geometric distribution is 1 over p. Next subject.
3%.
Let's see. A random variable x, where f of x is this, x is less than small. Okay.
This is less than small.
No, this is, if 0 is
Well,
nothing, less than 0 is less than
well,
small.
yellow, of fucking course. When x is less than small, it's gonna be 0.
Yeah.
Okay, so we take the integral from 0 to 1 of x times 2 over 3 6x minus 6x cubed dx. So if we look at the integral first, go up a bit. This is what we actually have to calculate. More brackets. Always more brackets, very important. This is what we have to calculate. But the thing is, actually, we can take this.
Why
We
is
can
it?
take
Why
the
is the
6
x
out of
there?
there.
Why is the x there? The one. So it's before the 2/3. There's an x. Why is that one there?
Because
Because that's how you do the expectation.
yeah, the expectation of x is equal to, or actually this is the wrong slide. You can use that slide as well, it works, but this one is easier. Expectation of x is equal to 0 to negative infinity to infinity of x times the function.
Which in our case is 0 to 1 because that's the bounds of formula.
Yeah, not clear.
So we take this thing. I have distributed the 6 out of here. This will actually become a 4. Because the 4 is just multiplied, I can get the 4 out of here. I can distribute the x in here, so that becomes x squared minus x to the power of 4. This is a difference of squared now. So then we get this. Well, that's just going to be frac
I get
1
1 to 0.
over
It doesn't
3.
matter how many fucking how many powers there are. Oh, actually, it does because you're gonna divide to the power. Never mind, I'm dumb.
1, 5, x to the power of 5. This dx can go away. Oh yeah, it doesn't like that. And again,
Don't
this
like
because it's 1 to 0, as Jelle said. So this is going to be, well, 0, blah blah blah. But this will be 1. So, but it's all multiplied by 4, so it's actually 4 over 3 minus 4 over 5. Therefore, it is 4 over 3 minus 4 over 5. There we go. I was going to say, and remember the expectation cannot be 0, but that's fucking false. It can be. Expectation can be 0. There's nothing wrong with that. Let's see. Cool. Scritch. Okay. Compute the... Oh, this is a fun one. So we have to compute the expected value of the outcome of the experiment. But that's not too hard. That is... I can do it in there. 0.1 times 73. Haha, it's the Bodhi number, guys. Plus 0 times, plus 0.2 times 93, plus 0.3 times 19, plus 0.2 times 86. There we go, 68.2 or rounded 69.
Yeah,
That's how you round.
Let's do ceiling. Ceiling.
Yeah.
Ceiling.
The standard deviation of a normal distribution is denoted by this. So the variance is this, standard deviation is this.
Yeah.
The variance of a binomial distribution is given by, and then we open the formula sheet, NP1 minus P.
I wish questions like that were on the exam.
Oh, I fucking wish, man.
Yeah.
What is the expected value of the test? 1 over 22 times 3. Actually, I could say 3 over 22 plus 5 over 22 plus 7 times 3 over 11 plus 60 over 11. $85 over 11. Woo! Next subject. Challenging questions. Okay. Ooh, that's actually interesting. So we need to calculate the variance. But I think the best way to calculate the variance in this thing would be using the using this formula. So we can take the expectation of x. So let me actually write that down here. So we have expectation of x is equal to minus 1 over 6 plus 1 over 3. And you guys understand why that is?
Yeah.
Cool.
Which is just 1 over 6.
And that's just, yeah, that's just frac 1 over 6. Then, the expectation of x squared is equal to 1 over 6 plus 1 over 3, because we square these things. So we have 1
Because it's
over...
x squared.
Yeah, exactly. X is the thing you're squaring, not the outcome. So this is going to be 1 over 6 plus 1 over 3. That's 3 over... Yeah, 3 over 6. That's 1 over 2. Does this work with this? I don't think it does. No, it doesn't. So I have to actually add these things again. And again, keep in mind, we don't need EX, we need EX squared, which is actually 1 over 36.
Hold on. Why is e of x squared a half?
Because it's
Because
you
it's
square
like
the x.
1 times this thing plus 1 times this thing. Because you're squaring minus 1.
Yeah. Yeah, of course. I was like, oh, but why doesn't the 0 term do anything?
Ha! You see, my fellow intelligent man. 0 squared is actually equal to 0.
Damn.
Yeah! And then again we do e of x squared minus e of x squared, or e of x quantity squared. So we get 1 half minus 1 over 36. Give your answer with 3 decimals. Why don't you suck a fat boy?
How about I give the answer with 2 fractions?
How about I give the answer infinitely precise?
That's good.
That's pretty good.
Delicious.
Yes.
Yes, it's like quite some precision actually. You see.
Oi.
I'm so sad Dark Crystal Age of Resistance was discontinued. It was such a good show. Anyways, Mats.
Cool. Oh, wow, Yellow, you actually bought Mist for the Oculus. Cool.
The variance of... Isn't that just like 9 times 6.1? Or is my math very wrong?
Yeah, I think
do
that might
yeah.
be. So we have var of x is equal to 6.1. Let me actually switch back to the singular braces. They're easier. Then we have the var of 1.4, 3x plus 1.4 is equal to 9 times the var of x. Again, because of the change of unit formula, not the change of variable formula. So therefore it is 9 times 6.1. The EX, completely irrelevant. So let's see. We can calculate the... We need to calculate the variance here, right?
Yeah, so we need to do the expectation first.
Yeah.
This doesn't correspond to one of the distributions.
Yeah. So we need the Okay, this is great actually, because that means we can just take the integral from... Yeah, so I'm gonna switch back to doubles again. So then we have the integral from 0 to 1 of 4x minus 4x cubed dx. However, because we want the expectation, we actually also have to multiply by x. So then we do this, we factor this one into the thing, then we get x squared. This becomes x to the power 4. I will take this thing outside of the brackets. Okay, cool, then this becomes 4 times 1 over 3 x cubed minus 1 over 5 x to the power 5 from 0 to 1. However, because it's from 0 to 1, it's just equal to 1 times this thing. The 4 gets distributed inwards. And then we are left with this thing. However, this is e of x. and this is not all we have to do. So because this is the expectation of e of x, let me actually make this a pretty number. So I'm gonna say this is 20 over 15 by multiplying top and bottom by 5, and I'm gonna say this is 12 over 15 by multiplying top and bottom over by 3. Then I will subtract 12 here. This will become 8 over 15, and that will be the actual expectation. Then when we use the expectation squared, is equal to a fraction of 64 over 225. And I don't think that has any common factors, because the bottom one
No.
is... no, it doesn't. It's like 5 times 5 times 3, and this is like 2 a bunch. Cool. Now we want the expectation of x squared. And these should be capital X's, by the way. Is equal to this integral. However, instead of x, we're going to be doing x squared. And that is because of this formula here. So again, we're doing x squared here, like that. And we are doing the limit because it is 0 outside of all of those bounds. Disputing that inwards will give 4x to the power of 3, and this will become to the power of 5. I will take this 4 out inward for same reasons as before. I will copy this. I will
Quick
down a
question.
bit.
Would you, why can't we just like, instead of working with 4x plus 4x to the third, why can't we work with 8x minus 8x to the third plus 3, and then like we don't have to work with the random variable 2x plus 3 anymore? Because I don't think we've done anything with this. Or...
No, not yet. But like when we have the variance of a random variable x, we can calculate the variance of this one really easily.
Yeah. True.
Yep.
But it would probably work the other way as well, right?
Yeah. If you do this one at first, I think it would work as well. It would make it a lot harder though.
Yeah.
Either way, let's do it first. So then we have 4 times. Let me actually take this one up front. This becomes fraction 1 over 4 x to the power 4 minus this becomes fraction 1 over 6 x to the power 6. From 0 to 1, recompile. I love how it's like when you do one thing wrong, it's like and then
Like
you
an
fix
ID.
it and it's like okay.
dx.
Oh, dx very important.
It's 0, Jure. It's all 0.
Yeah, you have some number dx. Okay, well, again, we know this is just 0 to 1, so this can go away, this can go away. These are just brackets, this becomes a 4, this becomes a 4 over 4, this becomes 1, so it's 1 minus 4 over 6. That becomes 2 over 6, that becomes 1 over 3. Okay.
You know, I like that one a lot more than ex squared.
Yeah.
So it's just 4 times 1 over 3 minus 64 over 225.
Yeah, so again, this is variance
Which is
of x
11
equal to
over
e of
225.
x squared minus
It's 44 over 225.
of x. Yeah. Let me be x squared.
Yeah. I'm just doing math.
Yeah. And then this will become 1
Let
over
the Euro
3.
speak.
This will become 64 over 225. Yeah, let's just keep it this way. This is good. And then we want var of 2x plus 3 is equal to 2 or 4 times var of x is equal to 4 times this thing. Let's see if we are correct. We probably are because we are very, very smart. Let's go!
Indeed. As
Okay.
such, I am very smart.
Wow. Okay, this is a lot more easy.
It's just x squared again.
Yeah.
It's the same one with the same thing, just they renamed from x squared to ey.
Isn't it a half then?
Let's see. So it will be Yeah, it will be 1/2. And now we went to expectation of this thing. Well, it's just going to be 1/4 plus 4/7 plus 10/7
I don't want to alarm you, but Jimmy is up 10.
8 times. Or actually, this is going to be 3 plus 9/14. And I want to be sure that this is correct. So this belongs to that one. That 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 belongs to that one. This is the first time in a while that Jimmy is up.
Why does this remind me of the time my physics teacher taught us how to in our head divide by 7 and get the decimals? It's not that. It's actually not that hard. It's 1/7 is 0.14287 recurring, and then for example, 2/7 is 0.285714 recurring. And so
Say by chance, do you have ADHD?
no, but I had a physics teacher who was. I probably do, but I also had a physics
I
teacher.
think,
Like,
I think
got
I'll. I
into our
think
brain for some reason.
I think most of us have it and just haven't been diagnosed.
I think most of us are
Yeah.
neurodivergent. That is.
Hmm.
Yeah.
Obviously.
Would you enjoy programming?
Yeah, quite honestly. Yeah.
I mean, if anyone is crazy enough to do 2 studies at the same time, they have to be.
Yeah. Okay, actually, guys, congrats on our green percent speedrun of part 1. We're at
Woo!
less than 5 hours for 4 things, so that's pretty cool.
Mm.
Now we only need to do
Yeah.
3 more, which are not that much, actually.
Yeah.
I feel like finishing it today, but I won't, because I also want to do some stuff
Yeah.
tomorrow. Well, in that
I mean, we
case,
have all
I'm
day
going to
tomorrow.
upload this part 1 onto YouTube already,
Ooh.
and
I hope we can do. I hope we can. Yeah.
well, in that case, if you
Yeah,
have any
go.
questions, let us know on Discord, and my Discord will be in the description, and have a good one, everybody from YouTube.